Hola, buenos días a todos. Muchas gracias. Bienvenidos a este Instituto de la Ingeniería de España. Y siento que no esté mi presidente. Ha tenido que irse por cuestiones médicas que tenía hoy. Entonces le estoy sustituyendo. Soy el José María Pérez Revenga, el presidente de la Asociación Española, el presidente de la Asociación Española de Transporte, el presidente del Comité de Infraestructuras de este instituto y estoy también en el soy vicepresidente del de transportes. Así que, tanto por infraestructura como por transportes, me toca hablar de estas nuevas innovaciones que son importantes. Creo que es muy importante, este es un tercer taller, evidentemente, para hablar sobre el tema del futuro, de lo que va a ser realmente los aviones, los drones, los elementos autónomos pequeños para las ciudades que falta nos hacen. Es importante, desde luego, las tecnologías han avanzado enormemente, es un tema complicado, puesto que la legislación va a ser complicada también el hacerlo, y debemos de tener mucho cuidado, puesto que la seguridad creo que es lo más importante para todos, no solo para las mercancías, sino también, evidentemente, para los habitantes de las ciudades modernas y nuevas, donde efectivamente van a regir estos aviones autónomos o drones autónomos o como los queramos llamar. Habrá que tener mucho cuidado precisamente en las Smart City para poder llegar a un acuerdo entre todos los actores. Yo siempre digo lo mismo. O sea, hay que sentar a los actores en los sitios donde hay que sentarles. Hablar, consensuar, dialogar, debatir y evidentemente luego aprobar. Pero hay que planificar sobre todo. Y planificar realmente lo que tenemos que hacer, cómo se va a llevar a cabo, quiénes van a ser los responsables en un momento determinado cuando eso esté funcionando al máximo. ¿Qué va a pasar con las empresas que lleven, evidentemente, o que tengan realmente estos elementos autónomos para las ciudades? Bueno, pues ese es un tema muy importante, muy importante. Tenemos aquí al CEDETI, que creo que es importante también, no solo para evidenciar, evidentemente, dar inversiones y dar un empuje a toda esta tecnología, evidentemente, que es el que tendrá que poner un poco en solfa también con el ministerio correspondiente o los ministerios correspondientes, no solo de Hacienda, sino también, evidentemente, de aviación aérea, etcétera, etcétera. Todo esto es importante y deben de ser estos talleres los que vayan resolviendo poco a poco todos los intríngulis de la nueva tecnología que va a existir. Son tecnologías nuevas. Las revoluciones industriales han ido pasando siglos a siglos y evidentemente esta es una nueva revolución. Revolución yo le llamaría tecnológica. Y desde luego el que no tenga la tecnología metida en la cabeza, mal va a ir de ahora en adelante, puesto que creo que es muy importante. La tecnología nos ayuda a las personas a hacer las cosas con menos esfuerzo, posiblemente, y con mayor capacidad de trabajo. Pero nada más. No quiere decir que la tecnología sustituya a las personas. Eso nunca podrá ser así. Las empresas las constituyen personas. Evidentemente, hay un CEO, habrá un presidente, etcétera, etcétera, pero son las personas las que sacan las empresas adelante. Y con las tecnologías pasa exactamente lo mismo. Son las personas las que van a seguir adelante en su apoyo, en sus realmente estudios, etcétera, etcétera. Bueno, yo realmente no quiero insistir más en este tema. Creo que es una jornada muy interesante. Yo, como he dicho anteriormente, presidente de uno de los comités de este gran instituto y vicepresidente de otro, he hecho ya varias jornadas a través de los comités sobre los temas de los drones. Y se han puesto en la palestra, se han puesto sobre la mesa determinadas dificultades, determinados problemas, determinadas cosas que hay que solucionar. Y yo espero que con estos talleres sean precisamente los que puedan dar solución a muchos de los problemas con los que nos vamos a encontrar y con las nuevas tecnologías. El coche autónomo le pasa exactamente lo mismo que a la aviación. Es decir, ¿qué es lo que va a pasar? Ya hay coches autónomos funcionando, y el problema es qué es lo que va a ocurrir con la seguridad. ¿Quién va a tener la culpa en un momento determinado? ¿Qué va a pasar con los seguros? Etcétera, etcétera. O sea, todo eso hay que verlo, hay que estudiarlo, hay que planificarlo y hay que ponerlo sobre el papel para evitar precisamente catástrofes que pueden ser graves y que pueden dañar realmente a las personas. Pues yo voy a dar entrada simple y llanamente a las personas que van a seguir y luego ya seguirán ustedes. Yo, por desgracia, me han avisado deprisa y corriendo que mi presidente no podía venir y yo me tengo que marchar, por desgracia. Pero bueno, ya lo veré porque creo que está grabado, o sea que ya lo miraré con el instituto. Pues yo doy paso simple y llanamente a don Antidio Vigueria, que es el coordinador del proyecto. Que es el coordinador del proyecto. Pues adelante entonces cuando quieras.
Hola, ¿me escucháis? Sí. Muchas gracias, José María. Thank you very much, José María, for the kind introduction. So I'm going just to briefly introduce IMO 3D project. IMO 3D project is a national project with a consortium of 4 technological centers in Spain. That we have a large activity in UAVs and unmanned air vehicles. It's coordinated by CATEC Technological Center. And the other 3 members are ITG, NITEC, and ICEA. So the main focus of IMO 3D is the development of new technologies applied to autonomous aerial vehicles and how these new technologies can impact in new transportation of people and cargo services. So we are very happy to have you here today. Welcome everybody. We hope you will enjoy this workshop that we organize with a lot of passion. Nothing else. So thank you very much for coming and attending this workshop, and welcome.
Bueno, pues vamos a seguir. Voy a dar paso a Roberto Trigo, que es uno de los responsables del CEDETI, de los que efectivamente tiene mucho que decir también aquí.
Pues muchas gracias, buenos días a todos y bueno, muchas gracias a Antidio y a los organizadores por tener la oportunidad de dirigiros unas palabras hoy. En primer lugar, no sé si en inglés o en español. Better in English? Okay.
Better.
All right.
Thank you.
Okay. Sorry, I will change to English then. First of all, I would like to apologize on behalf of my Director General, who was invited to be in this welcome ceremony, but fortunately, due to problems with the agenda, it was impossible for him. So I think probably many of you know already the CDTI, but for those of you, especially those coming from abroad that do not know who we are, the CDTI is the main public agent in Spain financing R&D projects for companies in all kind of sectors and different technologies around. One of them is aerospace, and here we have a very, I would say, a lot of money invested in the last years in this area, and in particular in the area of drones. I think that there is a growing interest in general in this area in all countries. A few days ago, we were gathered in the Ministry of Science and Innovation in an event also dealing with drones, also with CATEC and others, and this shows that there is a lot of investment brought into this sector, and a lot of public interest in the developing of the different technologies with regard to drones. I think that for the future, there are two main axes which are really important for this. And one is, of course, the technology, which has been developing in the last few years very strongly, I would say. And the other one is the regulation, which in this particular sector, as we all know, is a key issue for the future. I think as I mentioned before, in the event that we had a few days ago, we touched upon these two issues, and here again, I think in the agenda we have again a number of speakers dealing with that. It's another occasion to review where we are and what is coming next. Very important. Which is our role. Of course, our role is not the regulation for this. I think this is the Ministry of Transport mainly. Our role is in financing the technology to make it possible in the future. So for this, we have a range of different tools to help companies to develop this, and in all kind of different shapes, I would say. We have loans, we have the support to technological centers with different programs. We have venture capital as well for startups. We have a public procurement tools, and we have grants. So we have all the different elements that the public agent can use to finance the technology. And in which amount? This is an important issue. I think in this last period of 3 years, 2020 to 2023, counting also this year, I think it has been a period of a very intense investment in all kinds of technologies, but in particular in aerospace. Just to give you an idea, in the aeronautics sector, our calculation is that we will invest around more than 400 millions, 450 millions in this period, which is a substantial amount, I would say, for the number of Spanish companies dealing with technology in this area. And one of the main tools that we have right now for this is precisely a specific technological program for aeronautics called the PTA in Spain, that maybe many of you already know. This is a program which is funded by the European funds for the MRR, this next generation, the EU Next Generation program. And in this program, we have right now confirmed 160 million euros for investing in aeronautics in general. We have already assigned 120 more or less of this 160 million in two opportunities in 2021 and 2022. We launched two processes to assign these funds, these 120. For this year, we have another 40 which are assured for this. And we have the possibility to increase this 40 to 80 this year. So maybe if we are lucky enough this year, we'll have 80 million for aeronautic technology in grants, which will be announced shortly, we expect. With this program, we can fund all types of technology. But in particular, we have a specific chapter for drones, for this kind of systems here. So in the past, we didn't have maybe so many proposals in the last two editions of this program in 2021, 2022, but we still see a lot of opportunities here for funding. So this opportunity this year is very important. It's 80 million. It will be the last one in this period with the next generation funds. Next year, we don't know exactly if this program will continue or not. We are trying to see what happens with this. But this opportunity, I think, is very important for all of you. It will be quite a significant amount of money, and I think it's important that you have an eye on the information provided through the CDTI web for having a look at the how to apply for this funding. And I would not like to take much more of your time. So if for any question or doubt, if you want to have more information about CDTI and the tools that we have, I think one of my colleagues, Raúl García, is here. So, and you can, yes, is there. So in the coffee break or in another opportunity, you can address him and have contact with him for further information. And of course, through Antidio or in the web of this event, you will be able to find our coordinates somehow. We will manage that. So you can call us and we can provide you with the information you need. So thank you very much to all of you, and I wish you a very successful and useful event today. Thank you.
Bueno, vamos a ver ahora otro de los elementos que realmente son importantes, es la navegación aérea, evidentemente. Para eso tenemos aquí a Álvaro Fernández Iruegas, que es el director de navegación aérea, o ha sido director de navegación aérea. Muy bien, pues vamos a ver qué nos cuenta. Y a ver si se cumplen esos programas en los años correspondientes. ¿De acuerdo? Muy bien, te doy la palabra.
Muchas gracias. Good morning, everyone. It is a pleasure for me to participate in this third conference on the future of advanced air mobility of the eMove 3D project. Let me start by thanking all participants for coming here today, the organization for considering the DJAC, as well as the speakers for making this event possible. We can go to the next slide, please. There is no doubt that the global development of the drone industry has established itself as one of the vectors for innovation in the transport sector and sustainable mobility policies. In this sense, Spain has emerged as a European leader. After the entry into force of the European regulations, there are already more than 70,000 operators registered in Spain, and the improvements in efficiency and productivity in multiple areas are notable. For the year 2030, forecasts indicate that the economic impact could reach 14 billion euros and more than 145,000 jobs will be generated. We have to make these numbers possible. However, the sector continues to confront significant obstacles, especially when dealing with highly complex operations, such as those carried out beyond the visual range of the pilot's VVLOS, or those requiring different authorizations prior to operation. This highlights the need for all stakeholders in the sector, each one in our respective spheres of competencies, to develop services and systems that, through digitization and automation, can offer services with increasingly demanding and sophisticated drones in environments that are also progressively more complex and envisioned for a growing number of users. We cannot forget the obligation we have to ensure that this sector is accessible to all levels of the population and the national productive fabric. All these conditions come together in what we know as U-Space, a concept that will make it possible to lay the foundation of urban air mobility to ensure a safe environment. If we can go to the next slide, please. From an institutional point of view, in the line with regulatory and technological advances, one of the priority objectives of the European Commission transport policy is the development of a safe and efficient ecosystem for the operation and provision of services with drones. The Commission's 2020 Smart and Sustainable Mobility Strategy committed to adopting a new European drone strategy, which was formally adopted last November. To promote the new community approach at a high level, the Drone Leaders Group was formed with representatives from both the main regulatory bodies and the European industry. Among them, I would like to highlight our contribution from the Spanish General Directorate of Civil Aviation, which participate in the meetings and actions of the group that led to the publication of a report with the recommendation that eventually form part of the Commission's Drone Strategy 2.0. Thus, Europe's perspective for 2030 are that drones and their ecosystem are an accepted and integrated part of the citizen's life. The common goal is to consolidate the sector as a vector to achieve the smart and sustainable mobility of the future, fostering the creation of an open and innovative market for drone and air transport services and establishing a European strategic autonomy to offer new opportunities for economic growth. Our efforts must now be focused on supporting the adoption of these technologies, in particular promoting their public acceptance and, as I mentioned before, making them accessible to all citizens and entities. In this regard, the integration of drones within the same airspace of its other users is a huge challenge. Right now, the airspace for drones is essentially segregated from manned operations. However, in the long term, the goal is to achieve full integration that allows all users to operate freely in the same airspace. The implementation of U-Space emerged as the facilitator to initiate the paradigm shift and satisfy the need to integrate both worlds, starting with basic but complex mechanisms for achieving this, such as the dynamic reconfiguration of airspace. As everybody knows, we have created the U-Space National Deployment Action Plan, also known as PANDU, at national level, which has been established as an essential instrument for the coordinated development of actions focused on the U-Space system implementation during its initial phase. The plan was jointly developed by the DGAC, AESA, and ENAIRE with the collaboration of the Ministry of Defense and aims to involve all stakeholders in the sector. Later, my colleague Marina Stahl, head of Airspace Policy Area, will delve deeper into this topic and will detail the objectives and actions embodied in this plan. One recommendation, don't miss her presentation. On our part, the DGAC will continue to work to align national regulation with the latest European standard and promote the action of the PANDU, which addresses all the necessary areas for the effective deployment of U-Space in Spain. Airspace action focus on the development of national zoning, decisions on the national model for services and pricing, regulatory developments for its deployment, certification of new providers, and coordination with involved authorities. Next slide, please. It is equally important to address the impact of U-Space on military realm. Despite military aircraft operations being excluded from the scope of European regulation, the coordination between civil and military sectors is one of the utmost importance. Military authorities must be involved in the coordination and decision-making process regarding U-Space, as their participation is essential for ensuring the system's safety and security. Involving them in the U-Space deployment process is, therefore, indispensable for ensuring its proper functioning and the efficient use of airspace. This issue was at the core of the development of PANDU, which established a specific action focused on the collaboration and participation of the Ministry of Defense in our national working groups. And last slide, please. In conclusion, we must continue making our best efforts to promote the drone sector and make the future of mobility a reality. We must all be aware that there is still much work to be done, but I'm confident that we can accomplish it and ensure that Spain remains a reference in this field. I'd just like to finish by reaffirming once again my gratitude for the invitation to participate in this event, which without a doubt will help air mobility become a reality as soon as possible in our country. Enjoy the conference, learn, and conclude many, many things. Thank you for your attention.
Bueno, parece ser que efectivamente yo empezaba con el tema de la seguridad, de que todo el mundo tiene que estar atento, de que hay que sentarse en las mesas, de que hay varios ministerios, efectivamente, el de defensa, entre otros, está claro. Bueno, pues yo creo que la jornada es muy importante, importantísima. El año 2030 está a la vuelta de la esquina. El tiempo vuela, no pasa, vuela. Y entonces nosotros tenemos que efectivamente dar un empujón muy fuerte a todos estos temas para que todo salga bien. No solo la seguridad vial, la seguridad, la security, sino el safety también, evidentemente, para poder tener todo en orden. Y sin más, agradezco a todos ustedes, a los presentes, su asistencia. Muchas gracias por vuestras presentaciones, que francamente es importante, y al señor director del proyecto, coordinador, que siga coordinándolo y que efectivamente se apoye en todos los que se tenga que apoyar, en su equipo y los de fuera de su equipo, que seguro que tendrán algo que decir también. Muchas gracias, buenos días, y siento no quedarme a lo largo de la jornada. Buenos días.
Hello. So let's start after this welcome. And now that people arrived, so welcome also to the people that just arrived. So we will start with our first keynote. So it is my pleasure to present Giuseppe Scanapieco. He's a drones project manager at EASA, European Union Agency for Safety in Aviation. And Giuseppe, thank you very much for accepting this invitation and presenting the news from EASA. And we are sorry that you are not able to come to Madrid. You missed a nice dinner yesterday. But anyway, thank you very much for being able to have this time to present the latest news of EASA, what you have to do about innovative air mobility. Okay? Thank you.
Buenos días a todos los colegas de España. Thank you very much for your invitation to attend this event. It's a pleasure for me, of course, to provide you with an update of what's going on at European level when it comes to supporting the development of innovative air mobility, as you correctly said before, and support the development of drones in Europe. I have a small presentation that I will use as a reference to guide you to the discussion. And I would like to start. So hold on a second. Let me share it first. Share screen. Share this one. And hopefully it's properly being shared. Okay, good. So I would like to start giving you a reference, some information why we are not using advanced air mobility, although it's a quite, let's say, a very popular term that is coming mostly from the United States. We did some reflections when we started thinking on how to develop our regulatory framework for drones and VTOLs in Europe. And we looked at what was available already at other research entities or even other aviation authorities worldwide. And we came across the definition of advanced air mobility, which was defined by by NASA and lately adopted by the FAA. We found out that, unfortunately, that definition was not sufficient for us because it was not covering properly all the activities that fall under the remit of EASA and all types of operations that we are able to cover through our regulation. That's the reason why we came up with a new definition, with a set of new definitions. And we start from the top one. So, and then I will guide you in the other definitions and to explain what we mean. What do we mean by that? So the first one is a conceptual container, which we call innovative aerial services. Innovative aerial services are defined as a set of operations and/or services that are of benefit to citizens and to the aviation market, and that are enabled by new airborne technologies. So here it's important to note those three dimensions, so the three elements that are the benefit to citizens and the aviation market. The airborne technologies here, we are being, let's say, technology agnostic in terms of defining what could those such technologies be, and also identifying things like operations and services. So this is the conceptual container. And then within this container, we can identify two different main blocks, which are called innovative air mobility. And when we talk about innovative air mobility, here we talk operations that imply the transportations of passenger or cargo. And on the other block is what we call aerial operations. So all operations that can be performed, maybe with a sensor installed on board, but without necessarily implying the transportation of people, of passenger or cargo. So we defined innovative air mobility as the safe, secure, and sustainable air mobility of passengers and cargo enabled by new generation technologies integrated into a multimodal transportation system. Here is also worthwhile to note that we are developing this concept having in mind the integration of the air mobility component in the overall transportation system. And this is the concept that we intend to use at European level when talking about new forms of transportation that are enabled by such technologies. So that's the reason why, when it was funny, because when we were discussing the participation to this event, the initial title of this event was Advanced Air Mobility, but then we said, okay, you need to know that here in Europe, we are not referring to advanced air mobility because this is a terminology that is mainly used in the FA, let's say in the FA world, I would say, but rather we are referring to this concept of innovative aerial services and innovative air mobility. These definitions have also been, let's say, adopted by the Commission, and actually they are being transposed also in our regulation. A subset of innovative air mobility itself is what we call the regional dimension of the urban air mobility. And the urban air mobility is nothing else than a subset of innovative air mobility operations that are conducted within or out of urban environments. Opposed to this concept, so we may have also regional mobility or international air mobility, which is more or less the ICAO dimension when they look at the transportation of cargo, especially at this stage. But this is the overall conceptual approach that we took in designing the new regulations, and we try to implement in our regulation as well. So from now on, please keep in mind that we in Europe refer to innovative air mobility. When we decided how to deploy, what to give priority in developing new regulations, we had to take a look at what are the industrial developments in this sector. We know already that there are certain types of operations that are taking place with drones in maybe simple or medium complexity environments, And those kind of regulations, they're already, those kind of operations, they are already regulated by existing regulations that were published in 2019. But there is a need to enable more complex operations in more complex environments, like for instance in cities. And in order to do that, we had to put in place some appropriate requirements for that. We also know that there are many European stakeholders that want to start very soon operations with new aircraft concepts like Lilium and Volocopter. And especially for the second one, we know that they're targeting the start of operations on the opportunity of Paris Olympics, or the Olympics, or the Jubilee in Rome, or the Olympics in Milan between 2024 and 2026. What is important to remember is that at the beginning, these type of operations will still be conducted with a pilot on board. So this is a transitionary, let's say, scenario that will enable only later, towards the end of this decade, the performing of the similar type of operations like air taxi, for instance, but without a pilot on board. This will come, but not immediately. We foresee that they might come at a later stage, at a later point in time during this decade. In parallel, we also see the development of operations being performed in an international environment for the transportation of cargo. And this is more or less the scenario that is being addressed also at ICAO level, where new, let's say, SARPs, new standards are being proposed and discussed together between all ICAO member states. So as you see, not everything is going to happen at the same time, and also we had to decide what to give priority. Therefore, we have put in place, we have a plan, very articulated plan, where we are going to address these operations in a sequential manner. We published already a notice of proposed amendment in 2022, where we cover the airworthiness requirements for complex drone operations and the operational requirements for air taxi. But we are planning to issue additional NPAs next years to cover also the remaining type of operations. Just a recap on what is the current let's say, regulatory framework for drones in Europe. You know that in our architecture, regulatory architecture, we have identified 3 different categories of operations. So the regulatory framework is basically operation centric and risk-based, meaning that we are not necessarily mandating prescriptive requirements on the drones themselves and the operations, but those requirements are a function of what is the specific operation that is being performed. So we have 3 different categories. The open category, that is the low risk, so visual line of sight operations, 120 meter above ground, almost with even toys of those drones that you can easily buy in a tech market. We have the specific category. Here we have more complex operations taking place beyond visual line of sight in different scenarios. And within this specific category, we have also different level of risk that can be implied. And the specific operational risk assessment, so what we call the SORA methodology, is a tool that enables an operator to identify the associated risk and what could be the mitigating measures to be taken. For those kind of operations, we have already the regulatory framework in place, so Regulation 945 and 947, and also the acceptable means of compliance have been published as well. Now we are focusing on the last bit of regulation, which is where the most complex operations are going to be performed, because for those operations here, we are basically, let's say, going back to the 3 pillars of safety aviation. So we will be requiring a certification of the aircraft, we will be requiring a certification of the operator, and we will be requiring license, an appropriate license for a pilot. We have already consulted the first regulatory proposal in 2022, and we are almost ready. We plan in the next month to release an opinion that will go to the Commission and will be discussed at the Commission level. This slide just gives you an idea of how complex, what does it mean, and how many regulations we have to touch in order to enable this kind of operations. So basically, almost the whole EASA set of rules have to be amended in order to enable operations of manned aircraft systems in the certified category. And we will do that in a staggered approach, like I showed you in the first slide. Just a brief overlook on what we published recently. So just to give you an idea, where are we today? So the MPA that we have published in 2022 basically is made of includes 2 major blocks. So one block of amendments to existing regulations to enable the operations of a manned aircraft system in more complex environments, and also enabling the integration of those aircraft with manned aviation. And basically, what we did was to design the airworthiness process so the initial airworthiness, so the certification process for drones, and the applicable requirements for the continuing airworthiness of such drones once they are certified. Then there is a second chapter in our proposal, and this chapter is addressed to VTOL-capable aircraft operation, but manned operations, meaning that we still have a pilot on board. So strictly speaking, here we're not talking about unmanned aircraft systems, but we are talking about a new aviation products, new complex products that are going to be operating in a urban environment and interact with other manned and unmanned traffic as well at the same time. And therefore, here, so these operations are going to be some sort of transitioning measure towards unmanned aircraft operations. But here there was a need to define the requirements for the operations and the operators themselves, what requirements have to be established for the licensing of the pilots, and also regarding the rules of the air. So what kind of rules these aircraft are subject to when they fly in the urban or non-urban environment. Here, this is the outlook in the next 2 or 3 years of what's going to happen at our level. So on the first top bar, we see the MPA that we published in June last year, and we are targeting to release an opinion by Q2 this year. After that, all the appropriate discussions and processes will start at the Commission, and our target, at least our planning, is that those amended regulations will be adopted by the Commission in Q2 2024. In parallel, in order to support adoption of the regulation, we're also planning to publish another MPA, which will include the IMCA guidance material, so the acceptable means of compliance and the guidance material for those regulations, for those amended regulations, so that the national aviation authorities, the industry, the research centers will have a proper understanding of the regulations and will be able to deploy, to make fully use of those regulations as well. After that, we look to in 2024, by the end of 2024, next year, we'll be looking at proposing a new MPA which will cover the remaining types of operations, mainly the still operations with manned aircraft, but in this case, scenarios like IFR or VFR night. And for drones, we are planning to cover the requirements that are going to be mandated by the ICAO regulatory framework. So what we call in our concept, the so-called Type 1 operations. Here, the plan is to release an MPA by Q3, followed 1 year later, or almost 2025 with an opinion, and 2026, a possible adoption of the Commission. So this gives you more or less an overview of what are our plans and how we intend to support not only the industry, but also the national aviation authorities and other stakeholders that are interested in the development of this aviation sector. This roadmap gives you an overview of the task sharing between the national aviation authorities and the EASA. Looking back at 2022, you know that it was a very productive year for us. We published the prototype technical specification for vertiports design. It was the first worldwide set of proposed, let's say, prototype rules for the design of vertiports. We have also published the MPA which I mentioned before, and in December we published the MCA guidance material for the U-Space regulation. Then, as of this year, when we look at the bottom bar, so here it's likely that we will be dealing more in detail at the EASA level with the certification of the first VTOL operators. But we will also be looking at supporting the adoption and implementation of the rules applicable to unmanned aircraft system and VTOL certification to the member states. On their side, the member states themselves, they also will be busy this year with the certification of the first operators, aircraft operators. Also busy with designing the airspace and possibly the U-Space, as you mentioned before, and also dealing with the first vertiport authorization to enable the operations of air taxis in cities. In parallel to the regulations that are needed for the certification, so the airworthiness and the operations of drones, you know that we also been working on the definition of rules for the U-Space. So what is U-Space in a nutshell? U-Space is nothing else than a volume of airspace in which a set of services is provided by certain types of operators, and a set of information is exchanged between the actors that are flying into this U-Space. So this volume of U-Space is designed by the member states, is designed on the basis of a risk assessment, based on the needs of the specific member states, and also can be deployed either in a controlled or uncontrolled airspace. And typically, it's a fully digitalized system that enables the performance of so the flying of drones, so manned aircraft system, in an automatic way, in a safe and secure automatic way between 2 points of the airspace. It's also important that this airspace will have to somehow be able to accommodate on a need basis the presence of manned aviation. For instance, think about emergency services that are provided within cities where a U-Space is established, and therefore appropriate provisions have to be established. The same goes, for instance, in uncontrolled airspace, where maybe we would have a general aviation aircraft flying, but then these actors, well, these aircraft have to be somehow conspicuous to drones, and therefore, so that there could be appropriate deconflicting of air traffic between manned and unmanned aviation. The regulatory framework was established in 2021, and it came into force a couple of weeks ago. So there are three regulations: 2021 664, 665, 666. So basically, the core of the rule itself is the 2021 664, which establishes the provisions for the member states on how they need to designate the use space airspace. Also identifies what are the types of services that need to be provided and the service providers, and also defines also what are the tasks of the competent authorities. This regulation 665 establishes the provisions for air traffic service providers in order to enable the dynamic airspace reconfigurations of use space airspace in case of there is a need of a manned traffic to enter the use space. Whereas there is a last piece of information in regulation 666 that mandates the e-conspicuity of manned aircraft, so typically general aviation, when they're flying in use space airspace, typically uncontrolled. So this is the regulatory framework. And when we look at the roadmap for the deployment of use space, as I said, in January, so end of January, we started the regulation came into place, and it was adopted. But now different activities will start not only at as a level, but also at the level of member states. So as I said, at the level of member states, they will be looking at designing the use space airspace. There are certain member states that are more advanced in that, and Spain is one of those. Member states may also be busy with the certification of the service providers, the common information service providers or the use space service providers. On our side, we will be looking at the supporting the member states for the implementation of the regulation and defining the future evolution of the regulation as well. We know that there are certain pieces of regulations that need to be adjusted already based on the initial feedback. But we will also be looking at the first use space service provider certification, especially for those that are looking to operate in more than one EASA member states, and for which EASA will retain the important role of being the certifying authority for that service provider. So this is more or less what is going to happen. So now I think you have a better understanding of where are we going, where are we heading in terms of establishing the whole, let's say, key elements in order to support the deployment of innovative air mobility in Europe. And I would like to thank you again for the invitation. I hope you enjoyed my presentation. In case you would like to ask questions, I'm ready to take them on board. Thank you very much for your attention. I think I cannot hear.
You cannot hear me, no? Now? Can you hear me now?
Oh, yeah. Now, yes.
Now, yes. Okay. So, is one question?
Yes. Hi, Giuseppe. I'm Paul Frank from Lilium. Thank you very much for the presentation. I found it very interesting indeed. In your presentation, in the part IAM, if I read your chart correctly, the validation of the part IAM would be for Q1 2026. Is this correct? Because I had in mind that it would be like 1 year earlier than this.
Yeah. So you know that we have proposed with our MPA a new annex to Operational Regulation 965/2012, which includes the new Annex 9, Part IAM, which will regulate which will establish the requirements on the operators and for operation of people-capable aircraft. Our target is to release the opinion by Q2 2023, and we are aiming at an adoption of the regulation by 2024. So we expect that the Commission will finalize the approval of the regulation by 2024, and then it will be up to the Commission to decide the entry into force, but it's likely that will be, we hope that will be 2024. What we are planning for later is another amendment of Regulation 965, which will expand the scope of the 965 or Part IM to cover other types of operations, because today our first target will be day VFR operations. So, and therefore, all the set of rules that will come into force for 2024 will enable day VFR operations. And with the next regulatory activity, we are planning to cover the remaining operational scenario, like night VFR or IFR, for instance. So that's and for those looking at 2026 as, let's say, adoption of the regulation.
Okay, thank you. Thank you very much, Giuseppe. Any other question from the audience? I think you have not every day you have EASA to ask questions, so please don't be shy. There's one question over there.
Hi, Giuseppe. Good morning.
I think he cannot. One second. Can you talk? Can you hear him?
Giuseppe, can you hear me? Yes. Good morning, and thank you very much for your presentation. This is Nacho Rexac from Milan. Quick question on the roadmap you presented earlier. What is EASA having in mind in terms of IFR operations expected by, I think, 2030 or so? Would that be cargo air missions run autonomously?
Yes, thank you very much for this question. To answer your question, first of all, the whole set of regulatory proposals that you have seen on the screen, they always imply that we will have a pilot, a remote pilot somewhere on the ground. We are not yet regulating operations that are autonomous. We are regulating operations that entail a different level of automation, and where there will always be a human in the loop, so a remote pilot for the time being. We are also looking, so this is important to understand. So because sometimes people are confusing between automation and autonomy. Here we are regulating for the time being operations with different level of automation. Autonomous operations, that means the human is completely out of the loop, are not yet being regulated. Having said that, to come back on the question on the IFR Cargo International, you know that the ICAO framework is already in the process of establishing SARPs for regulating IFR cargo operations, and those SARPs should come into place by 2026. With our next MPA that we are planning by 2024, we are planning to cover those types of operations. So IFR Cargo International, meaning that still with a remote pilot somewhere, but the IFR cargo, let's say, environment, which is addressed by the ICAO framework. So that's our target. That's our target. The first proposal by 2024 and adoption by 2026, should everything work according to the plans.
Okay, so thank you very much. So again, thank Giuseppe. Thank you very much.
Thank you.
Thank you for your participation, and we hope to see you next year here in Madrid.
With pleasure. Thank you very much.
Okay. So yes, so let's now move to our second keynote speaker, Rocco Nanavecchia from Pipistrel Aircraft. He's a safety and reliability engineer from Pipistrel, and he's going to talk about the new development of Pipistrel in innovative air mobility. Thank you.
Yeah. Okay, this one. Wow.
That one. Yes.
Okay, thank you. All right, can you hear me? Yes, I guess so. A belated good morning to everybody. I'm Rocco Nanavecchia, Safety and Reliability at Safety and Reliability Engineer at Pipistrel Vertical Solution, the R&D division of Pipistrel. And on behalf of my company of Pipistrel, let me thank the consortium for this kind invitation. I'm truly happy today to be here with this room full of innovators. I'm pretty sure we will discuss a lot of interesting topics, and we will cover several points today. Sorry. I'm also pretty sure that I am the only one between you and the first coffee break, so I will try to be quick, even if my presentation is quite long. What I would like to do today is to present what Pipistrel is, what is our history, what is our vision, and what is our mission. But on top of that, I would also like to speak and present what is our contribution to the development and advancement of innovative air mobility, presenting you our product, Nuva V300. I will end up the presentation highlighting some points on what we would like to do in the next future. So let's start. So who is Pipistrel and what do we do? Pipistrel is a 33 years old light aircraft manufacturer. It's Slovenia based, but we are also the global leader in electrically powered airplanes. And this is stated by the certification of the only EASA type certified fuel electric aircraft, our Velis Electro. And our expertise in electric aviation and our will to innovate made us to become part of Textron eAviation in March. With this Textron eAviation, Textron eAviation is one of the 6 business segments of Textron, with the main goal of electrifying the future of aviation and making it greener. Textron eAviation is made by 2 leading companies. There is Pipistrel, that is developing electric aeroplanes and hybrid electric cargo VTOL drone. And then there is the Nexus team. These 2 companies complement each other, because we are developing a cargo drone while Nexus is developing a passenger VTOL. Pipistrel, as I said, is based in Slovenia. We have 4 facilities over there. 3 are over the border in Slovenia and 1 in Italy. We have the R&D division and the manufacturing and maintenance, and finally the prototyping, a special project in Slovenia, while our final assembly and production and flight test facility is just over the border in Italy. Pipistrel has already manufactured more than 2,000 aircraft. and that are operating in 101 countries or even more. We already count more than 270 employees, and as you can see, we have an expansive product line. We go from general aviation to ultralight gliders, but we have also already, as someone might not know, some experience with unmanned aviation. This is stated by our surveyor and about our NUVA that I will explain a bit later. So how we are already contributing to innovation? We are trying to innovate the aviation with electric flight and hybrid propulsion and hydrogen. As you can see, we try to give continuity to our project. We started with the Taurus Electro, and then we ended up powering the aircraft with hydrogen fuel cells. We flew electrically. We flew with an hybrid electric aircraft under an European project called MAEPA. This is the way we approach stuff. This is the way we approach innovation, and this is the way we will keep doing our work. So now, So now the main question: how is Pipistrel contributing to the development and advancement of innovative air mobility? Well, I tried to look up for a definition of innovation air mobility, and I like this one a lot. Innovation air mobility is an ecosystem supported by new technologies that is being designed for the transportation of goods and peoples to locations that are not traditionally served by the current means of transportation. So then I asked myself, how is Pipistrel contributing to this? What are we doing, and where do we wish to contribute to? So I looked up our website, and just to check where our basis, to start is. And I saw our vision and our mission. We try to shape the future of aviation by delivering cutting-edge solutions, but we also have the mission to significantly advance knowledge and provide highest quality products for the future air travel. And then I said, okay, here, this is how we wish to contribute to innovative air mobility. We want to leverage the expertise we have in revolutionary new aircraft design to provide and to offer a solution to move goods and among local communities that are underserved right now by existing mode of transportation. Another wild question that I asked to myself was, why right now? Why are we deciding to, 2-3 years ago, why did we decide to step in this world? Why are we pushing for innovative air mobility? Well, I tried to sketch this that give you an idea of the why. So I thought we have always the right ambition to innovate. We have the right technologies. They might improve, for sure they will, but right now they're already ready. We have the right expertise, but eventually there was also the right need. And I believe that when you have this right mix, I truly believe that today is your best day to make it better, right? To make it greener, to make it feasible. I will show you how we decided then to contribute to innovative air mobility, showing you a video, if we can play it, of our Pipistrel Nuva V300. Is there a way you can? All right. So this was a sneak peek of our Nuva V300. What is our Nuva V300? When Pipistrel decided to design our cargo drone, our hybrid electric cargo VTOL drone, we decided that we want something that was equally safe and reliable as the current means of transportation, but at the same time it was cheaper than the current means of transportation for cargo. This is why Nuva was designed with high-level safety objective in mind. And on top of this, we also wanted to achieve and offer operation to those remote areas, but also complex scenarios. This is why we decided to design the aircraft with a fully electric vertical takeoff and landing capability. But we did not want to stop here. We wanted to offer more an extended range. We did not want to limit ourselves to 50 or 60 kilometers, but we wanted to go beyond that. That's why we also decided to have an internal combustion engine, and this is why we have the hybrid configuration. We use the internal combustion engine to extend the range and serve way more remote location, connecting island to the mainland. What technology did we want on board? We wanted that the aircraft could perform beyond visual line of sight operation completely automatic, with just zero or little intervention from the ground control station operator, who's going to be there just supervising the operation. This is why we equipped the aircraft with an highly reliable and triple redundant flight control computer. Right now we are aiming to missions with a range of 299 kilometers away from the departure point, in constant communication via SATCOM to the ground control station. NUVA, as I said, is mainly for cargo. It's not for the transportation of people, and we aim at carrying more than 300 kilometers, going up to 450 kilo. To give you an idea of what is NUVA, NUVA has a 14-meter wingspan and has a maximum takeoff mass of 1,700 kilo. We can consider it as a large UAS, and it's a bit different of what you see already out there flying. What do we have in mind right now with NUVA? As I said before, we plan to start with low-risk operation, right? We plan to start with the automatic operation, but where do we want to go? What are we aiming at? We want to deliver commercially friendly and digital and connected air cargo delivery solution all over the world. We want to connected locations that are way far than 300 kilometers from the departure point. And we want to do that, we would like to do that, hopefully, in an autonomous way. So we will switch from automatic beyond visual line of sight to an autonomous beyond visual line of sight. Still with little intervention of the ground control station operator. We will just be at the ground control station supervising the entire fleet. A valid question, a fair question that I would expect from you is Pipistrel already doing something to achieve this goal, or is just speaking and talking and showing slides around? Well, Pipistrel is highly committed to CESAR 3 joint undertaking. We have already been part on one project. We are part and currently working on another project. And this is what we plan to do in CESAR. As I say, we want to offer new services. We want to offer new drone services in all kinds of airspaces, making what we call the concept of operation anytime and anywhere. We want to support the development of new procedures, technologies, and services. And this is why we are trying to be a catalyst of the modernization of the European air traffic management. How do we want to do that? We have a clear path, we have a clear plan. We started in 2021 with Chorus XYM. Chorus XYM was a project that is about to end, it's almost finished, where we had great success, and we wanted to extend the U-Space ConOps and also test and deploy U1 and 2 services. The results of Chorus will be the input for this project that we are now currently working on, that is called Welcome. Here we want to validate to a scalable market uptake of U1 and U2 space services. Welcome will be followed by so many other projects, I hope, all with the main goal to bring us to what we would like to operate. That means long range, large cargo delivery solution anywhere and at any time. Let me just quickly give you some picture and some results. It's important to share what we did and what we achieved to show you that actually something was done and was not only on paper. So as I said, Chorus wanted to extend U-Space ConOps and also deploy and test U1 and U2 services. Pipistrel was part of 2 work packages, the Italian one and the French one. In the Italian one, we ended up having 4 different vehicles sharing the airspace. We reserved the airspace to use space services, and we had the live tracking. Here we understood that this was possible with a good mission planning. And we also understood that we could use portable low-cost devices for tracking. That might be a solution for the future use space. In the work package 11, instead, Pipistrel was part of one of the 3 demonstrations where we wanted to test use space service provider capability of reconfiguring the airspace when a manned airspace was entering the use space area. And this is what we did with our Veris Electro. We required priority for a landing where an unmanned aircraft was flying, and we entered the use space area. So use space service provider cleared up our landing path, and we landed safely. This showed how the coexistence of manned and unmanned aircraft within the same airspace did not incur in any more workload on the pilot of the manned aircraft. And this is welcome. These results we will build with the project Welcome, where we want to further validate and demonstrate what we already did in Chorus. I will use some words that I heard during the kickoff meeting. With Welcome, we will try to create a bridge between research and actual business model. This is what we want to do, planning several demonstrations in 3 different countries with more than 50 partners. Let me conclude the presentation. What should we aim at? I know I spoke already about this, but what we should have in mind is that we would like to one day to fly anywhere at any time concept, and we should work towards this concept. We would like to have, maybe a solution for this would be to regulate the integration of automatic and autonomous large UAV within the controlled airspace. But not only there, we would also like to operate where use space services are present and where are not. Would be great if, also from the standpoint of the air traffic controller, if you didn't have any difference in dealing with manned or unmanned aircraft within the airspace. This will lead to so many other points, but we should also focus that not only complexity should be on the drone, but because technology is there, will improve, might get better, but we should not overcomplicate drones technology. They should be supported from the ground services and the environment services that are supporting the innovative air mobility. This is it. Sorry for being long. I shared with you my message and our vision. And if you have any questions, I will be more than happy to reply to them. Thank you.
Hello, good morning. My name is Ivan Maza. I'm professor at the University of Seville and ICEA, one of the technological centers organizing this workshop. So it is a pleasure to moderate this roundtable about UAM manufacturers with top-level participants from several companies in the sector in alphabetical order: Airbus, IHAM, Lilium, Pipistrel, and UMILES. I will briefly introduce each of the participants, ask a couple of questions about your companies, and then I will formulate 2 general questions to be answered by all of you. As I mentioned, I will follow the alphabetical order of the companies. So I will start introducing Jorge Chornique. He has been part of the Airbus UTM team since 2019, where he is currently leading the strategy and technical concepts. Before joining the Airbus UTM team, he has been developing the UAS and UAM strategy for Airbus helicopters, amongst other topics. In addition to his expertise on the strategy and UAS areas, he has held several positions during his career in Airbus, including UAS system engineering and chief engineer duties, which provides him with the right balance of market and technology know-how required to understand and implement the strategy for emerging markets. So based on your background, how the regulation is impacting the evolution of UAM operations?
Okay, thank you. I think when we look in Airbus to the development of the UAM, vehicle, we need to focus also on the ecosystem and the surrounding operations of it. And then if we look into the evolution of regulation, especially the outcome of the regulatory task force of EASA, the group 0 to 30, we see that we are not in an environment of a revolution, but of an evolution. We need to evolve from the current operations to the future vehicles, to the future autonomous vehicles. And this is something we need to cope and we need to be able to adapt ourselves. Just to put an example, most probably operations will start with a pilot on board. If we look for the very short-term timeline, the air taxis will not be autonomous, but they will carry a pilot on board. And looking into that scenario, then the question is, who will be the pilots of these vehicles? How will be the training, and which will be the impact of that into the operations? And it's something we need to take carefully, because even if today the approach is that we'll use existing pilots and then adapt for the type certificate of the new vehicles, we need to see the impact of that. Because we may have a lot of vehicles, of nice vehicles, but if they are not pilots, we will not be able to fly them. I think these kind of things, and this is just an example, is what we need to push together, so this evolution of the ecosystem can accompany the technological development of the vehicle and the certification of the vehicle itself.
So thank you. So regarding your answer, so how can UTM support the transition you mentioned from piloted UAM to unmanned eVTOL?
Okay, I think this is one of the other aspects of the ecosystem that we need to push. If we look into the existing approach, the approach is that the initial eVTOL operations with a pilot on board will be most likely like helicopters fly today. There will be some dedicated corridors, so we can ensure the air risk is reduced and we can ensure the safety of operations, but they will fly much like an helicopter. And then the question is, how can we support to fly more? How we can support for this evolution towards autonomy? Because helicopters today do not fly too much, even if there are corridors, even technology is there, because of other means. And this is where UTM can act as an enabler by supporting to fly more, to fly better in those corridors and to evolve into this autonomous concept of operations.
Thank you. So now I will introduce Nacho Rexach from IHAN. So Nacho Rexach holds a Master in Engineering and an EMBA and possesses almost 20 years of experience in the aerospace industry, where he has held senior management positions at Airbus and IHAN across different functions and countries. He is currently Commercial Director for Europe and LATAM at IHAN, where he leverages his expertise and knowledge in the aerospace value chain and his passion for aeronautics to develop urban air mobility around IHAN's cutting-edge autonomous aerial vehicle technology. So then my questions are, as an OEM, what are the main constraints for the development and deployment of UAM?
Okay, good morning, everybody, and thank you very much, IMOB3D, for inviting IHAN to this UAM roundtable. Speaking about constraints, obviously, I guess we all agree that regulation would be the first one. Technology is evolving way faster than regulation, notwithstanding the considerable effort made by EASA and the other CAAs to come up with very proportionate, bespoke certification standards for eVTOL technology derived from traditional or conventional aircraft and helicopters to enable their safe operation, and obviously not to withhold the innovation and the development of new technology. Now, having said that, and to be fair, we cannot say that the regulation is absolutely responsible for delaying the deployment of advanced air mobility, because even if we all had the regulation in place to operate our eVTOLs today, we would still need the rest of the pieces of the urban air mobility or innovative air mobility puzzle. I'm speaking about the US space services that will enable their operation safe, secure, and efficient under interconnection with conventional aviation and ATM. Also, the infrastructure is not ready, the vertiport, so we also need it. And the concepts of operations the new applications coming from operators and business models. So in summary, the regulation is just one part of the constraint, but we really need to use the time that it is taking to develop that regulation to build up the entire ecosystem. So when our platforms are ready to operate, everything else is set in place. The other point I would highlight would probably be the social acceptance. If there's no point in developing a technology if it isn't going to be adopted by any citizen. And if there isn't any demand, there will not be any technology offering, and thus there will not be any need for any regulation. So basically, we really need to take care on the adoptability of our new technology in order to ensure that there is a demand that will sustain this whole technological development. Fortunately, as you probably all know, EASA performed in 2021 a very exhaustive survey throughout Europe, interviewing thousands of Europeans from very big cities, ranging from Paris, Milan, Barcelona, etc. And it concluded that 83% of the people were really willing to accept this new mean of urban or innovative air mobility. And even 49% of them were actually willing to hop into an air taxi today. That was very positive. However, that survey also highlighted the fact that they were concerned about privacy, noise pollution, and obviously safety. And those are very important features that as OEMs, we really need to take care in conjunction with the regulators.
Yeah. So thank you. So coming back to the first point you mentioned about regulation, I have curiosity about how your company is coping with EASA EU space regulation in Europe.
Well, EHang, as the world leader in autonomous aerial vehicle technology, is a huge promoter of US space solutions. Basically, we consider it a key enabler for the urban air mobility services. So if we do not have those systems and those services in place and procedures, there is no way any of our platforms are going to be able to operate in a very slow volume of airspace above our heads over urban environments. So it's key to develop it. As such, we're really working arm by arm with our strategic partners, and we have developed specific collaboration agreements or are collaborating under specific public-private partnerships with the most important US space and common information service providers worldwide in Europe, in the UK and Israel, to help them develop those US-based services and common information services that will be key to sustain the urban air mobility. All of those services can be developed through simulation, through software, but in practice, if you want to validate it and to verify it, you need to run a very large-scale demonstration against them. And the only way you can do it today is against EHang platform, because it's the most mature and developed eVTOL existing today. It's the only one that has accumulated 30,000 flights up to today, over 10,000 flights hours as well. So in that respect, through those collaboration agreements and under public-private partnerships under CESAR joint undertaking projects in Europe, we are running very large-scale demonstrations with our partners to validate their US-based solutions and systems, and also developing concepts of operation that will basically guide the operation of eVTOL platforms in urban environments. Just to put a couple of examples, under Amulet project, we integrated our UAS with our partners, ITG and NTT Data, US Space Service, AIRUS, successfully, and performed an unprecedented, very large-scale demonstration in CR, in Rozas, in the north of Spain, just in October last year. Okay? And that really contributed to generating a lot of confidence, both on the platform, on the operation, on the technology, but also on the US Space Service. Okay? Now we're moving one step forward, and we're going to basically do the same under ULCAM project with 51 partners, and we will be performing very large-scale demonstrations in many cities of Spain, where basically we will test, validate through real flight demonstrations with our technology, U1 initial and U2 foundation and initial US space services to contribute to their market uptake.
Okay, thank you. So our next participant is Wolfgang Yu from Lilium. He is a trained aeronautical engineer and comes to Lilium with 27 years of aviation experience, having served in various roles in many regions across Europe and North America. He most recently was VP of pilot training and flight operations for Airbus military aircraft, and before that he spent over a decade in sales leadership positions for Airbus and NavBlue. He's a certified Airbus A330 pilot, and then, of course, he enjoys flying. In his current position, Paul Frank is the VP Sales and Business Development for Lilium. So then the first question is, what is Lilium Vision?
Okay, thank you, Ivan. Just one thing. So we all come from Airbus, right? It's almost embarrassing. I hope there's more diversity on the other side. Let's see. So anyway, thank you so much for the opportunity, Ivan, to you and to the consortium. Really glad to be here. So a few words about the vision of Lilium. At Lilium, we believe we have a mission. We are convinced that if we want to continue to fly and to move in general, we think that we need to do it differently in the future. So we want to fly passengers efficiently, comfortably, safely, but with zero emission in flight and very low noise levels. So that's the genesis of Airbus, I would say. Now, if we look at the vision per se, not only do we think that this new way to fly is sustainable, but beyond this, we are convinced that it will open the sky to much more people and in a sustainable way. So this is the vision, basically democratize sustainable aviation.
Mm-hmm. Thank you. In this regard, what do you think is specific about the Lilium approach to AAM?
Okay, well, maybe the first thing is listening to all my colleagues before. We do have a pilot on board, at least the first years. But overall, let's say that we are an eVTOL. We produce an eVTOL aircraft. Second, we target regional air mobility, what Jorge alluded to earlier. And the technology is maybe a bit special. The eVTOL, I would say this is of use for everybody in this room because it's what everybody knows: electric vertical takeoff and landing, so vertical and takeoff capability. But eVTOL means, as we said, no noise or very limited noise and zero emission in flight. I think this is very important for the future, and it might even be that it's impossible for helicopters, as you said, Jorge. In the future, for passengers, it might be banned in at least in Western countries. The other thing is regional mobility means connecting cities together, like from 50 kilometers to 300 kilometers, as opposed to purely urban air mobility. It is urban in the sense that you can land very close to where you really want to be, but in reality, you fly longer distances. The Lilium jet is, maybe if you can see in one of those pictures, is optimized for longer flight, fixed wing. So that's the specific about this model. And last, the technology. The technology, I would say, is distinct in some areas. The first one is the focus we have on the cabin. If you look at the shape of the aircraft, it consists of a large canard and a main wing, on which the extra large cabin for the category is lying. So this shows the big emphasis on the cabin, and the spaceship figure that we end up with, like on this picture, is only a consequence of focusing on the large cabin. Another feature which is probably worth mentioning, and this is very, very special in the eVTOL world, the jet concept. To my knowledge, it's probably the only jet concept in the eVTOL world. And this means something. The jet concept means, and this particular technology is more than a jet. It's a so-called DEVT. Sorry for the ugly acronym, but DEVT stands for Ducted Electric Vector Thrust. This means that you may have seen that there are 30 jets on the flaps of the aircraft. You can tilt the flaps as you wish to accommodate whatever speed, and you have differential thrust, and this differential thrust allow control of the aircraft. You might have noticed that on this aircraft, and it's probably striking for a pilot, there's no usual controls, there's no fin, there's no rudder, so no usual control that people are used to. So for pilots, it's a bit strange, but on the other side,
The vector thrust is what you get on the most advanced combat aircraft, for example, the F-35. And maybe the last thing, and I believe many eVTOLs and electric aircraft in the future will have this sort of technology, the fly-by-wire. I think this is very, very, very important, that in the future, flying becomes easier. Personally, I love flying. And when I got the first time in the Lilium simulator, my expectation that it would be easier to fly than the A330 I'm more used to flying. And as a matter of fact, all of us can fly this aircraft with a 10-minute briefing. You might need a little bit more proficiency over time to be rated, but at least it's very, very easy to fly. So this electronic fly-by-wire, I think cater for like safety. An incredible amount of automation to make it simple and accessible to much more people. A little bit like the passengers, but for the pilots. That's pretty much the concept.
Okay. Thank you for sharing your vision. Now we have Rocco Nanavecchia from Pipistrel Aircraft. So he's the safety and reliability engineer of the revolutionary Pipistrel hybrid electric VTOL and manned cargo Nuva B300 that was presented before at Pipistrel Vertical Solutions, the R&D division of Pipistrel. As part of his work, Rocco also holds the position of Pipistrel's SORA expert, and he's contributing with Pipistrel to make the advanced air mobility a solid reality for the close future through his contribution to several CESAR-3 projects, as you explained before. What is the added value for Pipistrel of being one of the main contributors of the future of air traffic management, its digital transformation?
Thank you, Ivan, for the introduction and for the question. Well, Pipistrel has already embraced digitalization to its products, right? So we already design our products entirely digitally, and we already deliver to our customer electric planes, digitally controlled. So Pipistrel, together with several other partners, would like to bring to the market novel technologies and new services. And to do so, we need digitalization. We really look forward to ways digitalization can help improve manned and unmanned product, delivering new enhanced onboard and connected technology and system that would be boosting safety and also the quality of the services, in particular when it comes to share and coexisting in the same airspace. This is an added value. This is a great point. We really look forward for that. And we really believe in this digitalization because we think that this is the way for industry partners to advance in the development of new technologies and new services.
Thank you. And what does Pipistrel consider crucial to fulfill your objectives?
Here, I will share some of the words already spent by the other panelists, and in one word is trust. We really need trust in drones. We already know and we are already aware of all the advantages the drones have. There's several applications already suit all our needs, from the transportation of goods and people, agriculture, medical services, wildlife conservation, but they also increase productivity and efficiency, among so many other advantages. But nevertheless, there are still challenges to integrate this within the airspace and within our environment. Therefore, I strongly believe that we need to raise a bit the public acceptance. And to do this, we need shared knowledge of what we are doing, because people don't know a lot, don't know enough about drones and the benefits they could bring to the society. And when they will understand this, of course, their perception will change and the public acceptance will increase. I strongly believe that the best way to do so is a joint effort from cities, municipality, regions, country, technology provider, and operator. This is the way to go. In particular, from authorities and cities, because they are the first one to engage with the citizens, and they are the first one to put their trust out there. If they trust our drones, citizens will start trusting our technology, will start trusting autonomy, right? And another good way, and I truly appreciate already those communities that are involved in European project like CESAR, I believe CESAR is the best way to de-risk our journey towards that final goal, right? Because in this way, there are municipalities that are welcoming the development and the demonstration of those technologies that are not yet regulated, right? So having this demonstration, real-life demonstration that will actually reflect the operation in the near future, it's crucial for the development of all our products.
Thank you. And now from UMiles Next, we have Manuel Valenciano. Is eVTOL product director of UMiles Next and leading all air programs of UMiles Next and their relations to infrastructures. He has 25 years of experience in aerospace industry with experience in all the phases of aircraft design, manufacturing, and assembly, and experience in the principal OEMs of civil aircraft of the world, Airbus, Boeing, Embraer. So my question is, how does UMiles Next face the new sustainable intermodal mobility through your solutions?
Grateful to stay here with you. And UMiles has an idea to change how all of us move inside the cities. So for this reason, UMiles has a full suite of solutions who goes from ground autonomous mobility to air supply services. For instance, an example of can happen in the future is you need a ground service to go to a vertiport. This take to a vertiport. In this vertiport, we have a control system for the arriving and takeoff and landing. And there is waiting for you an eVTOL that could take you an airport or perhaps a golf course or your business place in a specific building. So UMiles is very concerned with the sustainability and with the intermobility and present a global solution for all the movements in the city with the purpose of have a clean air and no contamination or pollution inside the cities.
Thank you. So another point that was mentioned before is safety. So what does offer UMiles eVTOL in terms of safety?
Well, UMiles is very concerned with the safety and is a must for us. We have developed with our partnerships in technological partnerships a new system called Fly Free. It's a patent and we have patented. This system has an advantage in control of the aircraft. What happened really is consists of the motors and in the turbulence that the aircraft can suffer react, equilibrating the aircraft, and the passenger has a more comfortable sensation, because it's important for us, like my colleagues say, that when we deliver this aircraft to the market, the sensation of safety for the passengers has to be enough, because they don't going to fly again in our aircraft.
I think this is a very important point. So now I have 2 questions for all of you. First one is, by when can we fly sustainable and close to the cities? So we can follow the same order as before if you want. You can start, Jorge.
Well, I think we can already do it today. I mean, the thing is to get scalable and to do it better. But today we can fly with certain degree of sustainability, and we can fly in cities, and we can see that. The thing is that we cannot fly at a scale. We need the technology to be more sustainable, the technology to be more safe, and we also need to attract the customers and to embrace the utility of these new kind of vehicles. So I think What I think is that in the end it will be, and I mention again, an evolution. I don't think we'll see from one day to another, and there's hundreds of vehicles flying in the cities. I think we start to see more and more, and with the regulation, with the new technologies, with the new vehicles, we'll start to see more and more until they become something that we see daily.
Yeah, building on from what Jorge has said, which I completely endorse, I'll be a bit more aggressive, I would say. EHang is going to fly commercially in China this year. We will get the type certificate this year in China. We expect a German OEM to get the type certification under EASA in Europe next year. And in 2025, probably our US colleagues will follow under FAA certification specifications. Even though, and this is my personal view, entry into service, that is commercial operations of US eVTOLs or eVTOLs in the US, may be postponed a bit further in time because they are lacking and they are a bit delayed in terms of US-based UTM development, which, as we mentioned earlier, is a crucial element for UAM operations.
Okay, let me try to add to this. First of all, I completely share what my colleague just said. If we look at the sustainable journey, I think it really is a journey, as Jorge says. It has started. It has started with, it's a major objective for next gen, the US with the FAA, with CESAR. It's one of the major pillars to reduce emissions and to reduce pollution in general and reduce noise. So I think there's a lot being done right now on like the flight trajectories, for example, PBN, RNP, SBAS, you name it. A lot about alternative fuels like SAF. There are, I think, ambitious projects about hydrogen fuels. And there is the electric domain. So the electric domain is probably more for this audience today. As far as we're concerned, certification for 2025, and then you can fly as early as 2025 your electric jet.
I also share the words already spent by my colleagues, and therefore my answer is soon. I mean, urban air mobility, innovative air mobility is not a matter of science fiction anymore. It's already there. There are already some VTOLs testing out there. The regulatory framework has already set the basis, and this is really important because it means that we are not so far from where we want to get at. Plus sustainability is, technology is ready for sustainable aviation already. Will improve, might get better for sure, but we already been flying for 10 years in electric, so this is also a statement that can be done. Therefore, I really have high hopes that this will happen soon.
Well, my aportation here, like my colleagues, is the same. We were ready in 25, but it's open new opportunities with the vertiports, with the EU space and business that have to be done. This takes 1 year, or I don't know, perhaps 2. And probably we fly during these years, testing and so on.
So thank you. So it will be soon. But what do you think could accelerate the AAM implementation? You can follow the same order.
Yeah, I think I will insist on one of the topics that my colleagues mentioned before, and it's about creating the trust in the society. I think that for that, our role as manufacturers is really to be honest with regards to the technology and what can be put into the public. I think it's important to put the end customer, to put the society at the center. So I think we shouldn't avoid to be technology push and really to be pulled by the needs of the customer. And we need to be able to translate all the technical speech into really the impact that has on people. Because when we talk, for example, about the safety rates of the vehicles, and that's in the end is a number, but that means that yearly we can have 1, 2, 3 accidents. This is something that people need to know, and people need to be acceptable. When we say that they will fly, okay, these machines fly, but they do not do teletransportation. So if there is 200 people coming out of an A320, and all of them want to take an air taxi, we'll need a long queue of air taxis to carry these people, and we'll need a large infrastructure to have these vehicles. And this is something that people need to know. And this is something that will support to accelerate and to evolve into the embracement of this technology.
From my side, I support what Jorge said, and I would contribute with a concrete proposal. I would suggest a real UAM operational sandbox. Okay, here in Spain we have great test flight centers. I'm speaking about TR, speaking about Atlas, speaking about Zeus, and soon there will be a fourth, I guess. The thing is, we cannot afford to spend out of 6 months project time frame, 4 months with permit paperwork and administrative bureaucracy. We really need to calibrate the risk of the operations, establish those well studied test centers, and really perform very large scale demonstrations recurrently with integrated US-based services, with flying eVTOLs, with prototypes of vertiports to develop concepts of operation. As Jorge said, the trust is key. So unless we get operational experience, we will not convince the regulators to ease a bit on the requirements. And we will not convince the society of the benefits and the accessibility of this technology to their day-to-day life. And in addition, unless we see it flying, operating with specific applications, it will be difficult to convince investors to put money into this new emerging market.
Okay, Ivan, thank you for this opportunity of wish list, for the advanced air mobility. I just hope that you have direct access to Santa Claus to get it delivered, but great opportunity. Maybe to add, I completely agree, to add a few other points. I think for electric aviation particularly, I think we need electric power supply strategy per country. This is not necessarily very obvious with the recent facts with Ukraine, etc. I think that all countries, took very seriously the power supply in general and energy supply. But this, I think, requires some more steps to get electricity in one given place with one given standard in power. Another thing is regulation. So this has been mentioned several times, but I just want to reiterate. And one fact in particular, the fact that right now there's one regulation for the US and one regulation for Europe. And if nothing is done, this will be two different worlds with no standard, and this would be really sad. So if we want to continue the globalization of aviation, I hope that EASA and FAA can get together and come to agreed standards. So I would add, those two.
What I would like to add to what I already said, so in addition to the importance of having demonstration in a European project, and so already starting to demonstrate how the operation will look like in the near future, something that I guess still has room for improvement is the regulatory framework, also for large UAS, because this incomplete or under construction regulatory framework is limiting a bit the scale of large drone complex operation. And this way, this will slow the progress. This will limit the innovation and raising some barriers probably. Because right now, in particular for testing of these drones, it's a one-off difficult waiver that we have to go through every time we want to start a new kind of operation. And connecting to what I said before, we also need some trust from the authority out there for the technologies that we are developing. I know that they are the ultimate responsible for the risk. Sure, I really appreciate the work they are doing with the regulatory framework and all their effort, but I guess there is a real need of streamlining the entire process of approval also for testing. Otherwise, we risk to have the framework, the environment, and the services, but not having the products ready to exploit those services. We need a process of approval of the operation that is predictable and easy. I mean, easy, but also in a broad way, you know, in order that doesn't take so long to complete a flight test campaign or to start operating somewhere.
Well, I totally agree with my colleagues. The thing is, we have to simplifying the messages is we have to make the regulations more simpler. And for instance, the other day I was in a summit in Madrid in Alcobendas. There are autonomous vehicles delivering pizza. So the autonomous vehicles are here to stay. So next step, for instance, Japan is a roadmap, has a roadmap with vertiports and with vehicles, high vehicles, making the test the next year. So if we do this here, like through a sandbox, like my colleague said, we stay ready sooner.
Thank you to all of you. So now it's time for questions from the audience.
Well, thank you very much to all the panelists for the wonderful explanations. And I got a question for Frank. And maybe it's a little bit of a technical thing. Looking at your aircraft, the Lilium aircraft, I'm wondering what are the gliding capabilities of the aircraft and whether those could be issue for certification if they are not there.
Okay. I suggest that you are talking about a total engine flame out or total.
Yeah, coming from that, but certainly you go 30. I understand this safety argument already, but I'm not so, let's say, familiar with what are the new regulation rules that will apply to you, whether you will be forced to, you'll be capable of gliding anyway.
So first of all, the aircraft can glide, obviously, particularly being a fixed wing. Now, it requires some power because you still need to be able to move your flaps. I said flaps, but it's not really flaps. It's flaps, aileron, eleven, everything at the same time. So as long as you can manage this, then you can make your fly symmetrical and you can manage. Now, it's all a question about what is your remote failure, what is the acceptable means of compliance for certification, and well, this is obviously within the standard. By the way, 10 to the -9 failure per flight hour, which is the standard for eVTOLs, which is I think very high. I would like to remind that for regular aircraft, people may not remember that say that you have a total hydraulic failure on any fly-by-wire aircraft, the aircraft becomes uncontrollable. So yes, it can glide, but it can glide provided you have a minimum technical standard to safely land your aircraft.
Thank you.
More questions there?
Thank you very much for your questions and answers. So I think I heard from anyone that he would imagine a future in which flying is like more, in general, more accessible and easier and a more automated experience. So to do so, I was wondering to what extent it is possible to, or you see an opportunity for gradually integrating new technologies like artificial intelligence, and if so, how do you see the next 5 years, and what are the main blockers and challenges to do so, especially regarding to safety and certification? Thanks.
Okay, maybe I can give you one argument, and my colleagues can help me out. But basically, artificial intelligence is already, I think, including in aviation, not so much in the aircraft per se, but much more on the ground segment. So in air traffic management, but Jorge will know better. in air traffic management right now, you do use artificial intelligence for the concept of follow the green on the ground. So on complex airport, the so-called AMCCS level 4. So that's a big one. You also use it in tower automation. You also use it in time-based separation in towers. So you do use artificial intelligence in many ways right now. In the future, there's also a plan to have automatic spacing, and this will require artificial intelligence and interoperability and connectivity within the aircraft and air to ground with real-time exchange of trajectory. So all of this is already in the roadmap of CESA. And beyond this, what are you going to do in autonomous flight? This is not for me because you guys are much more knowledgeable.
Yeah, I think I'll take it from there. Basically, in terms of autonomous operation, it has to be completely coordinated through US-based services. Okay, US-based services will probably build upon artificial intelligence, right? Not for the initial and foundation services, but thereafter, as the volume of drones grows and the amount of operations that have to be controlled in time increase, they will need to leverage AI. And this takes us back to my initial point about operational experience. AI is basically an instrument that relies on big data. It needs to have a lot of operational data behind to execute its calculations, algorithms, and decisions. If we do not fly, we do not get that operational data. And without that operational data, we will be condemned to UTM governed by humans. And that's something that is simply not feasible. Today, we have, just to give you some figures, around 25,000 commercial aircraft flying worldwide. The expectations are that we will have by 2040, 160,000 passenger carrying eVTOLs concentrated in very small volumes of airspace, concentrated between cities and over cities. So the amount of operations will be increasingly condensed, and there will be no possibility to control that air traffic simply by a human. We really rely on automated, digital, and artificial intelligence. And it is all driven by operational data, which we really need to urge and generate fast.
Just to complement the answers by my colleagues, I think the challenge we have with artificial intelligence today is how to certify it. Because today, all the critical safety equipment and systems in the aircraft on ground need to be certified, and today's certification is based on a deterministic approach. I know what every processor will do with every input and every output they will deliver. And with artificial intelligence, we are losing that concept, because the system is able to react, and react based on its learning, not based on a deterministic approach. And this is why there is a challenge. EASA is working with that, with the more relevant stakeholders in Europe. The FAA is doing a similar approach. And this is really key. Just to put an example, the prototype we did in 2018, the Bajana vehicle in the United States, already was using artificial intelligence for detecting birds and detecting a small aircraft that could be in their route. And this is a system that we validated. We have over 1,000 flight hours with Bajana and with this system in several of them. But then to certify the system is not so simple, and it's not straightforward. So I think on one side is the applications and the use and the extensive approach we can make of these systems, but then it's how to certify, how to make trust of the artificial intelligence systems.
But ChatGPT will not make it all.
Thank you. Just one question, which is not engineering. Sometimes in the presentation that you guys are fully funded. maybe. Thank you.
Well, I can respond in from EHang side. EHang is publicly traded in Nasdaq. We were the first urban air mobility company listed in the US. So basically, we rely on the value of our shares. And obviously, in a market which is yet to explode and to come into our reality, there's a lot of private financing also required. And that's something that all OEMs are all watching out for.
Can complement that. So Pipistrel is self-funded by Textron Aviation, so we are not really dependent on investors. We are really focused on our product, and we will make it happen on our own. And plus, right now we probably don't see us as operator of our aircraft, but mainly as supplier of the aircraft. So it's not really for us.
Well, Miles is a Spanish company, and all the investors came from Spanish investors. And yes, we are open to store, obviously, like the market demand in this kind of vehicles.
No, it's just nothing to add except that at the end of the day, I find it odd that nations and Europe will not invest much more in this sort of sustainable aviation. When you look at the funding, so Nacho just mentioned, like the Nasdaq and the US in general. So this is where you get most funding. As a result, this is where you get most investment in eVTOL, but not only eVTOL, in sustainable aviation in general. And I find it a bit sad that there's no more focus in Europe and with public money, because this will benefit to all of us, not just a few. Thank you for the question.
So I don't know if we have time for one additional question. Yes, we have time for one question.
Good morning. Thank you for your presentations and your answers. I would like to ask about the subject related to training, how you are in your companies doing the training, let's say initiatives, or how we can think that all the technologies like simulation could add value to the UAM world.
Okay, so that's my favorite topic, right? But no, but training and eVTOLs or even drones are, I think, almost two different topics. Regarding, I think it's important to remember, and maybe to say, we are all aviators here. I think it's important to remember that eVTOL and drones are not that different from what we are doing today. The fact that we change the engine, there's no big deal. You see what I mean? So I think people think about everything that could go wrong. Well, it's not obvious that something will go wrong. Actually, the plan is to increase the level of safety. Okay, so training has no reason to be different. The reason why training will be different is actually what you said about simulation. And this is the natural evolution of simulation, much more immersive technologies, AI, as the gentleman was asking before. Within the immersive technologies, you have Google's, so that you can have light devices. You do have self-training thanks to AI and Google's. So you can compress your training faster in a much cheaper way and using the new technologies to train. But this will happen for all aircraft, not limited to eVTOLs or even drones. The drone pilot license, if we talk about pilot, maybe the question was for every member of an operation, but if you talk about the drones, the pilot curriculum right now for drone pilot is very, very similar to a regular pilot. So in my opinion, there's no reason to change because of eVTOL, but there is a reason to change because we have new technology available, which we'll use across the board.
Yeah, I think I fully agree, and I think that for us in Airbus as a traditional manufacturer of aircraft, fixed wing and helicopters, this is highly integrated into our concept since we designed the vehicle, how will be the training for the pilots, for the operators, for the maintenance personnel. But I think also that if we look into the very long term, and now I think projecting 30, 40, 50 years from now, if we go to a highly autonomous environment, what will be the role of training is something that somebody needs to start thinking today. Because if we don't have a pilot on board, if the maintenance operations are fully automated, if the manufacturing is fully automated, which is the role of the human operator, which is the people that need to be trained to do what with this system, is a question that sooner or later we need to start thinking of. So I think really to see how this concept that we have today of training, because the women are still at the center of the operation, and that will evolve in the next future. This is something we also need to start thinking.
Yeah, on autonomous operations, or rather automated operations, as Josep explained earlier, basically the concept doesn't differ that much. I mean, EHang, as pioneer in this technology, provides training to its operators, both in terms of maintenance and operation. The operation is obviously not focused on an onboard pilot, but a pilot operating the UAS to the ground control station. Okay, so it's a certified training program as well, following a syllabus structure and also the pedagogical structure dictated by the corresponding CAA. And it's simply a question on evolution. I mean, we are all aware that this new technology, this new mean of air mobility is taking us to autonomous. I'm pretty sure that by 2050, there will not be many aircraft piloted by people. So all of these pioneering advances in terms of operation, maintenance, training of autonomous aerial vehicles, something that is going to render a lot of experience and knowledge for the rest of the aviation sector.
Okay, so for me it was a pleasure to be in this roundtable with top-level participants like you. So thank you so much for sharing your very valuable vision with us. And now it's time to close this session. So thank you so much.
Sí, voy a mirar. Este hombre representa a este hombre. Ese. No pasa nada, vamos bien, vamos bien. Vamos bien de ahora.
Okay, so now let's continue with our third keynote speaker after this very interesting roundtable of UAM manufacturers. So it's a pleasure to present Kenneth Kirkop. He's the director from Dronamics. Please, Kenneth, where are you? Okay, perfect. So let's give an applause to Kenneth that he's going to talk about Dronamics and their vision. Thank you very much.
Very good. Okay. Let me get hold of this. Okay, that's perfect. So, good afternoon. I'm Kenneth Kirkhope, General Manager of Dronamics Airline. First and foremost, it's a pleasure to be here. Thank you for the invitation. It's a very interesting conference so far, with a lot to learn and very interesting discussions. So, what am I here for today? Basically, I'm here to present Dronamics. And Dronamics is working on the future of cargo mobility. Now, how is Dronamics composed and what is the vision? So Dronamics is a company that started 8 years ago. It started basically our founders, the Rangelov brothers, had this vision of creating a solution, building a solution that delivers cargo on a long range, so we're talking about thousands of kilometers, using a drone. And this project, of course, took a long time. I will explain in much more detail in the coming slides where we are today and how we aim to achieve that. But before doing that, I think it's important that I give a little bit of an insight how the company is structured. So the company, we've got a holding company that is based in the UK, but then when we come to the research and development and innovation, the company is based in Bulgaria, and this is where most of the activity has been going on. In reality today, this company already employs around 150 full-time employees. So we're not talking about a small startup. It's a fully fledged company, but of course we are still in pre-revenue stage. In recent months, actually a year ago, we also registered the operational part of the company in Malta. And what we're building is effectively an ecosystem whereby we design our vehicle, but within a subsidiary of the same holding company, we operate the vehicle. So the solution will actually sell cargo capacity, but will not be selling the drone. And how do we aim to achieve that? First and foremost, I will get into more detail about the system that we have created. And why do I speak about a system? It's true that we have a drone. The drone is the one you're seeing there. It's a fixed-wing aircraft. If you look at it, you wouldn't realize it's a drone. The only difference is that the pilots are actually on the ground. But of course, given that it is a remotely piloted system, we didn't design only the aircraft, but also the ground control station and the communication links between the two, so that we have a full system that will be able to operate. Of course, what is the business model? To be efficient, to be affordable, and to be sustainable. Our focus is not urban air mobility. So it's interesting to see that the title of the conference is Innovative Air Mobility. And we focus primarily on regional airlines. On regional environment, whereby our solution has a range of around 2,000 kilometers, carrying a payload of 350 kilograms. So effectively what you can put in a small van, you can load it on an aircraft and it can actually fly this distance. How is it done? It's done with a single engine that is a Rotex certified engine that is used a lot in general aviation, certified, and therefore it is a solution that has been tried and tested, and we know that we do not expect any difficulties in actually running and maintaining it. So let me get a little bit more into the detail on the operational side. So what you see on the left side is the drone. As I mentioned before, it's a fixed-wing aircraft. It is remotely piloted. I think the differentiating factor, I've heard the presentations, the panel discussions of different solutions that are very, very interesting. And one of the differentiating factors from our side is that, yes, we fully believe in autonomous flight, but we are taking a stepped approach. And the stepped approach is that we are pretty much ready to fly, fitting into the current regulations, because we have a system that is very, very conventional. And what do I mean by that? As I mentioned before, it's an aircraft. The aircraft is equipped with what an aircraft normally has. So whether we're talking about the avionics systems, whether we're talking about conspicuity, whether we're talking about controllability, and so on. And we have pilots on the ground that are actually flying it. So at this stage, we're not talking about autonomous and someone overseeing, but it's the other way around. It is the pilot flying through an autopilot like you would have on a manned aircraft, with the difference that the vision is straight away to approach autonomy as we go along, and therefore we have a roadmap on how to start increasing autonomy as we go along, when we build more confidence in the system, but not just us, also the regulators in what we're doing. So once we have the drone, of course, we need to operate from somewhere. And where do we operate from? In our case, it's a conventional takeoff and landing, and therefore it means that we need an airstrip. The airstrip can be any type of airstrip. Initially, we'll be flying from established airports, of course, not extremely busy ones, because we'd like to remain within regional environments. And in order to set up a drone port, what we need is what a normal aircraft would need, with the exception that we need an additional ground control station. Now, when we're setting up these drone ports, in reality, it's quite a simplistic process. We have different models of ground control stations. We've got those that are fixed, so where we want to go and have a permanent presence, yes, we built something that will last and is not mobile. But then on the other hand, we've got ground control stations that are installed in a vehicle, in a van, that actually is driven from one place to another. You pull up the antenna, of course, to ensure that there is line of sight within the terminal area, and in a very simplistic way, a drone port is set up. Where are we in this process? Of course, we are setting up our drone ports as we speak. By the end of the year, we expect to have 3 drone ports that are already operational, and of course that will grow. But I will explain a little bit more how we are approaching this process. More than that, when it comes to mobile ground and cargo operations, there's not much to say other than it is the same infrastructure that an airline would need. So our solution is very much fitting into infrastructure that is already there, and we're just fitting in, setting up our operation with the rest of manned operations already existent at different airports. As we move along, we'd like to move to remote areas, and that would mean that instead of operating necessarily in airports that are established, we can move into small airports, we can move into even unpaved airstrips and set up there. But that's something that we will do in the future. So a little bit more detail on the drone itself. The drone itself, we call it the Black Swan. Of course, it's not black. To be honest, when we started, we did have a drone that was black. This is the new livery here. The wingspan is actually 16 meters. As you can see, it is a fixed wing aircraft that is more like a glider. In reality, that's where we get the efficiency from, the fuel efficiency from. It can carry a payload of 350 kilograms, as I said before, in a space of 3.5 cubic meters. So from the drawing board, the drone was designed to create as much space for cargo as possible. The range it can fly is around 2,000 to 2,500 kilometers. Currently, it is powered using a Rotex engine, using unleaded fuel, but of course sustainability is very important. So in our roadmap, when we start operating, we'll operate with synthetic fuel. using the same Rotex engine. We have agreements with net zero solutions in the UK that create this fuel, and therefore it ensures that it minimizes our carbon footprint. But of course, we would like to move towards hydrogen technology. It's not readily available, so we'll not wait for that. But in the meantime, we do have agreements with Cranfield Aerospace Solutions, where we're working on solutions already for the time when those solutions become available. When it comes to speed, the speed of the drone is 200 kilometers per hour. So, of course, it's a slow-moving drone, and the altitude that it operates is up to 22,000 feet. So usually we operate at flight levels 150 to 180, potentially at a maximum ceiling of 220. The fuel consumption, as you can see, is extremely low at 5.8 liters per 100 kilometers. So I mentioned a little bit about the drone ports. Why have we created this model? The reason is the company designs the drones, but we will only manufacture the first few models of each variant. So apart from that, we entered into agreements with the likes of Quickstep in Australia, with the likes of Cotesa in Germany. And once we start our operational ramp up, we'll start mass manufacturing a number of drones every few weeks, and would like to deploy those. So of course, in order to deploy those, we need to ensure that we have the right setup in order to grow quickly. And the way to do that is to fit into current infrastructure, into current operations, into current processes that are already existing in aviation. And that is the model that we are following. Network Operations Center, how do we operate our fleet? So I already mentioned that we have ground control stations. Now, of course, ground control stations are there for our pilots to actually fly the drones. We will be operating BVLOS. For obvious reasons, if we're flying 2,000 kilometers, there's no way you can ever fly in line of sight for the entire journey. So the method that we have chosen is that we have ground control stations that are based at every drone port. Within line of sight range, we control the drone using radio links for obvious reasons, because they give you bandwidth, they give you very low latency, and for the rest of the cruising flight, which is the largest phase, we use satellite connections. So the ground control stations are there to really fly the drone. But then we are building an airline. So we are building a network operations center. This is central. So our ambition is not to operate in Europe only, but we started with Europe. So in Malta, where the base of the airline is located, we are building a network operations center just like you would have in any airline. And what do I mean by that? In the NOC, you have all the coordination, whether it is flight planning, whether it is dispatch, whether it is crewing and rostering, whether it is actually sales quotations and dealing with freight forwarders. It is the entire ecosystem under one roof. And that will ensure that we have an efficient operation for a growing fleet size. I'm sure you appreciate that an airline having a fleet of 10, 20 aircraft is a lot to handle already, let alone the big airlines having 100 in a fleet. Of course, over here, we're looking at an operation that will grow over 100 drones in a few years. So, of course, we need to start from the ground up. What we don't want to do is cater for the 2 drones that we start flying, and then when we want to scale up, we're not ready. So we're building a parallel process where we focus on the vehicle, but also focusing on the operation, with a management team that comes from the airline industry, that have done this already in the airline industry, and therefore it is a matter of adapting a model that works to something that is slightly different in reality. I would say that in my experience when I took up this job, when I started looking at certain solutions together with my colleagues, at first we started looking at the drone industry, right? Products that are developed for the drone industry. In reality, what we realized is that we more fit the airline model, with minor differences, as I said before, because the pilot is on the ground. And therefore, our focus went in that direction, and it makes perfect sense for the business model that we have. So when we come to the concept of operations, we have spoken a lot about regulations, of course, technology having advanced at a much quicker pace than regulations. In reality, we're building the setup of a normal airline. What do I mean by that? As a presentation earlier on, we've seen what the requirements are to operate a drone. In our case, of course, those are the basic regulatory requirements that we're looking at, but we're not looking at those only. What we're looking at doing is really meet also regulatory requirements that apply to an airline operator, to an AOC. And in that respect, our organizational setup respects that. So on the operational side, we do have an accountable manager, we have post holders that are coming from the airline industry. And apart from that, of course, we have all the training processes, the refresher training, what is required in the airline business, in the aviation business at wide, applied to our model here. The concept, of course, involves infrastructure. As I mentioned before, the infrastructure requirements are similar to an airline, with the difference that we have a ground control station as well. I keep mentioning that because it is part of the system. There's it's no point talking about a drone which is remotely piloted without also taking care of the ground control component. The key processes and procedures in this respect follow exactly an airline model, with all the ConOps looking at aircraft operating matters, looking at training, looking at ground operations, what have you. What you would find under a normal AOC, you would find under the model that we have created. Finally, and this is very important in the panel discussion, this was mentioned regarding pilots. Our model is to have commercial pilots. So just to give you an example, our director of flight operations for many years was a training captain on the A330, coincidentally, and all our pilots are commercial pilots with significant experience. Why is that? Does it have to remain like that in the future? That's something to be seen. But we want to ensure that when we start on day one, the people that are actually controlling this aircraft understand the importance, the criticality of the function that they are actually doing, and also the accountability. How important it is to be accountable, because this is an aircraft. So of course, if something happened, the implications are significant, and we want to ensure that we've got the people with the right mindset. Of course, that extends beyond pilots, but I wanted to mention pilots because they are in control in command of the vehicle. Moving forward, of course, that is the ConOps. Just like a normal airline setup, we have our simulators. What is the difference between a simulator for an A330, for a Boeing, and for our drone? I wouldn't say there's much difference, for the simple reason, of course, we're talking about something fixed base. The pilot is usually in a ground control station flying the drone in the air. In this case, in the same setup, in a room, but this time around, they are not actually flying the drone, but they are actually flying a model. But that gives them the confidence and, of course, the experience in flying the drone. Just like anything else in aviation, of course, we've got a management system, we've got a safety management system, which is absolutely important, and an emergency response plan. I'm getting close to the end of the presentation, but I wanted to highlight that Dronamics, perhaps not a lot of you have heard about it so far. We are hoping to make big news later this year. And how are we managing to achieve this vision? It started 8 years ago. I would say in the last couple of years, there has been significant progress. And in order to do that, of course, we're partnering with key suppliers, with key consultants in the area. And this is across the board, whether it is the design, whether it is the manufacturing, whether it is the operation. How has our journey been so far, and where would we like to go? As I said, the initial years were more building the concept, building a small scale. In reality, over the last 3-4 months, we have been flying a subscale model, a quarter size of the drone that we have built, that has most of the avionics systems that are the same. Of course, from an aerodynamic point of view, it is very, very similar, simply smaller, but that gained us a lot of experience also on the processes. Where are we now? Actually, last year we obtained operational authorization at Sail 2. That means that we can actually fly our drone primarily over the sea, and that gives us the possibility of conducting a flight test campaign, and following that, flying our first commercial routes. Where we are right now is really that we are literally in the final steps, in the final few weeks, in order to start flying the full-scale drone. So it's fully integrated. We are doing some final ground tests before we actually fly it. The plan is an extensive flight test campaign that will last probably until the end of summer. By then, we'll start flying our initial commercial routes. Now, when I talk about this, what is the plan? Will we always fly over the sea? Because currently we have a Sail 2 authorization. No, it's not the case. We have started a design verification process. We hope that within a year or so, we manage to obtain this, and that will allow us to get to Sail Level 4, which will allow us to fly in more environments. But then, of course, the ultimate aim is to move towards Sail 5, 6, and ultimately type certification, while we are flying, while we are already in the revenue stage. That brings me to the end of my presentation. I hope I wasn't too much, didn't overrun too much, but I'm happy to answer any questions you might have. Thank you. Good afternoon.
Yes. Well, can you hear me?
I can very well.
My question is, I see, thank you for your presentation. I see my name is José García Navarro from Airbus Defence and Space in Getafe. I see your product, or your aircraft is focused on civil applications. Are you thinking also military applications? Do you know that in the European Union also there is some needs now of the MODs just to have this kind of application in the military, for military logistic, military rescue, and so on? What about this?
Okay, it's a very good question. Thank you for that. It's a question that we are asked very, very often. And of course, at this stage, we do not exclude anything. What I can tell you is that for the launch of operations, our focus is cargo. And in fact, that's where the drive is. We have a number of agreements with, big companies that require our services and have committed to use our services. But moving into the future, I would not exclude anything. So it's something that will be considered definitely as we grow.
Good morning, good afternoon. My question was in relation to the concept of command unit. Not sure whether your aircraft would fit the description, but last summer in the MPA 2022-06, the concept of command unit was subject to Part 21 certification requirements, which diverges significantly from other jurisdictions like the FAA. So I wanted to ask how that would affect you here in Europe, and then how would that translate into your efforts to expand to other markets?
It's a very good question. In reality, I would say that we sort of anticipated it, not that we were sure that it was going to happen. And this is the reason that when I said we're preparing and trying to meet the requirements that you would for a normal aircraft, but of course extending that to the additional item, which is the ground control unit. From the manufacturer side, so from the Bulgaria side, we are already working towards obtaining Part 21, Part 145. So these are all in the plan. And to be honest, I'm not seeing that it will affect in any way our plan, because even if it does not become a regulatory requirement, we will be there in any case. Of course, what I would say, I mean, my background before joining Dronamics, I was leading the air traffic services in Malta, and of course there you don't have Part 21 requirements, but the requirements on air navigation service providers and their equipment is at the highest level because of the safety criticality and the essentiality of the service, and we're looking at it from that point of view as well. So I would not say that it will change our plans. It will just confirm that we were on the right path.
Thank you.
Next question.
Oh, thank you. Could we go back, please, to your second slide, possibly? The one with the specs?
Let me try.
Thank you. Yeah. Okay.
This one?
No, the one with the specs.
This one?
No, it was one. No, another one much earlier. Probably it's first. Yeah, that was. Sorry.
This one?
Previous one, I think. No, next.
This is the first slide.
First, second, third. Sorry.
Second, third.
Yeah, that's it.
Okay. Sorry, I'm rushing.
Right. Thank you. I'm curious about this figure on the carbon footprint, which is 60% less CO2 today. How you come to this figure in terms of cost or carbon footprint per kilogram per mile against aircraft of comparable size or against the average of the industry?
Primarily, that was compared to where we focus the business cases, and the business cases, regional areas, especially replacing road transport. Okay. So let me give you an example. Just one place that we are looking at, but not necessarily in Europe. We will start operations in Europe, but further to that, of course, we're looking at other regions. And if we look at, for instance, Australia, if we look at Africa, these places, they lack certain connectivity that is currently on the road using trucks that are, of course, emitting. The emissions are quite significant, and the journey time is significantly long because the connectivity is not there, the road infrastructure. When we compare that to our solution, as we're saying, without at this moment in time, this calculation is without hydrogen solutions, talking about synthetic fuel on the Rotex engine that we have already. So it's something that we can literally fly and go. It's not something in the future. Those are the figures that we end up with. Of course, in the future, we expect those to be better as the technology develops and we move from synthetic fuels to actually hydrogen solutions.
I totally agree. Even so, this 60% figure is quite striking. It's really, really large. Among the main three technologies you have put in your aircraft, which is the sailplane type aircraft and the Rotax engine or the maximization of cargo or cargo factor? Which would be the most important factor towards this reduction, you think?
I would say, personally, I believe that it's a mix, but the design of the aircraft itself, it is very much a glider. What do I mean by that? Of course, we're looking at long range flights. So the climb and the descent is a small part from the overall flight. And actually keeping the aircraft in the air in cruise requires minimal propulsion in order to get it from one place to another. And I think that is the key, the largest contributing factor to that calculation.
Thank you.
Thank you.
You have further questions? With the lunch. So now let's continue the next round table.
Make it.
Okay. Hello. 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 Well, let's continue to this second round table. So about BB-loss operations, and let's do a quick introduction about BB-loss operation. As probably all of you know, it stands by beyond visual line of sight operations, and we really think this is the real point that this new sector is going to be able to increase exponentially. Right now, most of the US operations are focused on VLOS operation close to the pilot, and we really think that the possibility to scale, not only to perform one demonstration, but to scale BB-loss operation is a key issue in order to create a real sector that can increase a lot in the next years. So it is my pleasure to present the participant of this BB-loss operation. Here with us we have some of the companies that they have performed most of the BB-loss operations in Spain. And I think if you are so kind to introduce briefly yourself so people know who you are. Thank you.
I think that they don't hear you.
No, it's okay.
Hello?
Yeah.
Okay. Hello, good morning. First, I would like to thank you to Antidio to invite to this roundtable. My name is Javier Pancorbo. I belong to Telespacio. I'm a program manager in operations division, and we are in charge of the HEOSUB program, who is going to try to develop BB-loss operations in non-segregated space and try to combine these missions with geo information collecting from a Copernicus program. Okay.
Hi. Okay, good afternoon again. So Kenneth Kirkhope. Of course, I've just done the presentation, a little bit about myself. Really, my background, I started off as an electronics engineer, so that is really my background before I moved into aviation about 15 years ago. Spent quite some time in academia at the University of Malta working in aviation research and so on, so I really like this environment, of course. Moved on to air traffic services in Malta for 6 years. I was the CEO there, so I learned a lot about ATC and their traffic management. And for the last year, I've been with Dronamics, and I'm the general manager on the airline side. Thank you.
Rafael. Thank you very much, Antidio. Very glad to be here with the whole consortium to participate in this roundtable. My name is Rafael Marquez. I'm the current Business Development Director in Artec Solutions. I'm a telecommunications engineer with more than 15 years of experience in the aeronautical industry. And my company, Artec, has developed his own fixed-wing UAS system that is named Tarsis.
Thank you. Carlos.
Yeah. So, hi everyone. Thanks for the organization for counting with us. I am Carlos Matilla. I am the CEO and co-founder of Fubex. I am aerospace engineer and MBA. And what we are doing is to replace crew helicopters for long-range drones in power line inspection. So right now, in 2023, amazingly, conventional helicopters continue to be the gold standard to inspect power lines. And we want to change that. And we are already performing BVLOS operations in Spain in segregated aerospace. Thanks.
Hi, good morning, everyone. My name is David Pérez Piñar. I'm the head of UAS development in Babcock. Thank you, Antidio, for giving me the opportunity to take part in this roundtable. And we are basically trying to develop and to put in service a UAV. We are developing a UAV, but any UAV that is capable of BVLOS operations, which are complex operations, are our goal, because we are focused on emergency services, and that is basically complex.
Okay. Well, thank you very much for this brief introduction. So let's start with the first question for everybody, and I think we can start with David. Okay, so backup. No, you have already performed some BVLOS operations. What is your experience performing this operation? What also are, in your opinion, the major bottlenecks for the scalability of these BVLOS operations, so we cannot just perform demos, but everyday operations?
I think first a brief clarification. I think there are two levels. We need to differentiate between operations and flight. There are UAS operations and there are UAS flights, and the conditions to make it happen, each of those cases is kind of different, because operations provide a lot of additional requirements, additional restrictions, and things like that. It's different to fly, for example, looking for power lines, or to fly in a firefighting operation. That's completely different requirements. In my opinion, the main bottlenecks from the technological point of view, I think one is to ensure the UAV is visible and see everything else in the airspace, which is kind of sense and avoid and technologies like that. And the other one, I think it's pretty important, is communications. It's to ensure communications. And we are talking about beyond visual line of sight flights, operations. If you operate offshore, over the sea, in principle, there is no problem. If you operate onshore, there are mountains, there are valleys, there are everything. So you can't fly 100 kilometers because your communication systems have that range. It has to have that range, and you have to be able to make the data go from one point to another, and there are obstacles there, everything else. I think those two technologies are key for this. And I think in the communication side, the mobile communication support will be key also for this.
Yeah, thank you, especially for very low level operation, but yes, that's for sure. Carlos, your company performed, it ended grow more than 1,000 flights last year, BVLOS. So tell us your experience. What is your experience performing BVLOS? What are the major obstacles and bottlenecks that you face in order in 2023 to have even more flights?
Yeah, so just to be clear, we are here I think the smallest company by far. So one thing is very complex is the regulation. At the end of the day, safety is communications, as you said. We were speaking before that we probably have met in Galicia, so you can imagine there vegetation, you can have orography, and to make all the things work, because we are working about the client wants the power lines done in a privacy manner. The regulators want to keep the safety, and at the end of the day, you have to pay all the bills. So the complexity, again, regarding the client, the operation, regarding regulation, and at the end of the day of paying all the bills is very complex. So right now we are seeing that the sector is starting to allow these kind of operations. There are some business models that are rising, and that's great because we have seen through all these years that we have been in this sector, great companies that were in Spain, such as Usol or Flytech, that they were at the top of the game at that moment. And my experience is that I have seen companies die left and right, and hopefully right now we are in the moment that money is coming to the sector. So the regulation is one huge challenge that we have to face.
I'm surprised that you never mentioned still U-Space, but let's continue. So I'm surprised, but Rafael, so Artec also is your products also dual use, you have also performed flights in a lot of places, also in Atlas Tech Center. So please share your view. How do you think your experience performing this type of flights and the major bottlenecks that you are facing right now in Artec?
Yes, for sure. As designers, manufacturers, and operators of the Tarsis family, we have a lot of background performing this kind of operations. I don't know, maybe 5 or 6 years ago, we started with this. We have arrived from more than 90 or 100 kilometers working with our Tarsis. And as you mentioned before, mainly focus on the military domain, but also in the civil one. And performing different kind of operations, let me say, because we have been involved in R&D projects with specific demonstrations purposes, but as well we have performed services for third companies. For example, we have been working with a telecommunications operator to integrate 5G communications into the Tarsis to test this technology. So according to our experience, that I think is nice, the bottleneck for me is not the regulation, because the regulation is there, and we have to try to solve the problems that the regulation are stating. So for me, there are 3 pillars that are the availability of services, U-Space, let me say the first time. Second one is the technology, and I mean with technology the way we solve the problem, for example, with detect and avoid, or the availability of vertiports and infrastructure to fly. And the third one is the procedures, the regulation at the end of the day, how we will manage these recurrent activities that up to now is not possible to tackle. So this is my point of view.
Thank you very much. Kenneth, you commented your company, very interesting one, a very large UAS. So how do you see this BVLOS operation, and what do you think are the main bottlenecks that can avoid to start the scalability of these BVLOS operations? I think you have to. Yeah.
I keep forgetting that. I think from our point of view, as you rightly said, we're talking about long range and a big aircraft. So of course, the requirement is BVLOS. In fact, our pilots never actually, even if they're very close to the drone itself, they never see the drone with their own eyes, because they're closed in the ground control station and they are controlling in that way. So BVLOS is absolutely critical for us. Now, from my point of view, I would say that this will very much develop with the advancement and the take-up of and the regulation in favor of autonomous operations. Why am I saying that? So, as we are right now, autonomy, I wouldn't say is not allowed, but let's say it is difficult in order to obtain the necessary authorizations. So from our point of view, we see as the command and control link as being a safety critical link. Being a safety critical link that brings certain stringent requirements, and therefore we use a mix of radio links, but the radio links have to be within line of sight of the drone, and satellite connectivity, right? And with satellite connectivity, there are certain difficulties when it comes especially to latency. As we move towards autonomous operations, what I do anticipate is that the requirements on the link will go down for the simple reason that the drone is behaving on its own to a certain degree. But in the meantime, there is quite a period of time, whether that's 5 years or 10 years, I don't know. And from my point of view, I think we need ground-based solutions, technical solutions, whereby instead of us, the operator, setting up an antenna to have radio connectivity where we need it, just like in normal aviation, if you've got CPDLC, if you've got certain other solutions that there are transmitters, transceivers that are, all along a big territory like Europe, and there's full connectivity. I think those solutions should be applied also to provide BVLOS connectivity. I think the focus is not there a lot for the simple reason that most operators are looking at 5G mobile connectivity if they are in low levels, but that does not apply to us. So certainly we need another solution.
Yeah, no, I totally agree. And this ground infrastructure is also, as you said, there's not much focus there, but it will be key, for surveillance, for communication, and so on. It will be very important. So yeah, thank you very much. So Javier, so now Telespacio has started this new project in the Civil UAV initiative in Galicia. You have this challenging objectives as self-free BVLOS operation. So how do you see the close future?
Well, in our program, we try to combine BVLOS operation in non-segregated aerospace with geoinformation coming from a Copernicus program. In that sense, we try to develop new technologies that try to promote the use of this BVLOS operation, like detect and avoid technology, an evolution of navigation UTM services with a specific integrity concept that we can apply to US to manage in a better way these operations, and also to want to develop an advanced communication device to give the proper link between the remote pilot, ground station, and the platform during the flight. From my point of view, from a safety point of view, all technologies have to demonstrate the needed maturity level to get the target safety level required by the regulation. No, so in the end, we need to overcome the concerns, the doubts from citizens to accept this kind of operation. Mainly in urban scenarios, no. So this is an important challenge for all of us, and in the end, I think maybe we need a common technical specification or common operational rooms if we want to facilitate the integration in the common airspace in the future, no, for this kind of operations.
Thank you very much. So let's now talk about US space. So how do you see US space? Do you think it will be the enable, the miracle that we need, to make BVLOS operations? It will be enough just for to perform some kind of BVLOS operations. do you think it will help you to integrate into ETM in the future? So, Javier, I don't know if you would like to start.
Well, I think the initial national strategic plans associated to US space was defining at high level, so probably many questions related to BB were outside of this initial definition. So now the focus had to put in this type of operation in the new version of the US space. In that sense, I think that this is an important roadmap, an incremental roadmap for facilitate the performance of this operation in the aerospace. So we expect improvement in this line.
So, Kenneth, I know you are at least far away from the initial US space, but do you think it could help in the future, in order to integrate or enhance ATM?
Okay, from my point of view, as you rightly said, I don't anticipate that EU space will be at the levels that we need it anytime soon, right? So, of course, our focus is not there, and the solutions that we're looking at are really in exploiting the digitalization of air traffic management. And I think with that, through CPDLC, through the right communication links, that there are regulations in place already, and the deployment is actually happening right now. Those would be enablers for us for the initial phase of operations. However, as I mentioned before, we would like to move towards autonomous operations. We're not in a rush, but eventually we'd like to be in that space. And in order to enter that space, yes, we need U space in that case, I would say. So definitely it's positive to see, to start seeing U space being created, being used, having USSP set up, having operators that are using it, because we'd like to fit in that environment. But of course, we will not wait for it in the meantime.
Okay, thank you very much. So, how do you see AirTech? How do you see US space? You think it will enable these BVLOS operations? And also, if you can mention if you think that this concept could also be translated for dual use in some way.
Yes, for sure. We think that it will be great to have these new services available. In particular, in the civil domain, we think is one enabled to have this flexibility to have more activity with end users. For sure, when a private company decides to invest money in some technology, expect to be returning this investment, and we need this flexibility to achieve this kind of operations. But I know perfectly that the national and European regulators are working hard on providing these digital and automated services from US space with dynamic reconfiguration and so on. But I want to highlight one point, that is the time to resolution. Because when one private customer asks us for provide a service, he doesn't want to wait several weeks or months. Mm-hmm. He wants a quick answer. So if the services are available, but the time to resolution is not agile, for us, for a private company, it will be very, very difficult to face this situation. So let me state this point.
Okay, very, very interesting. Carlos.
So what is the end goal of the sector? And in our opinion is autonomous operations. We have already spoken about that, but how much time are they going to take? And if we think about this end goal, yeah, US space is an enabled technology. There are other technologies that will enable this system. But the problem is that the transition we are living, because we are not close to that at any point. So if we wait to the deployment of US space, we will be lost, because it's going to take some time, and we have to already to work. These are very hard technologies, as we all are aware, and we need to try to do things independent of US space. It's great to be a part of projects such as Welcome, that is going to develop the technology and trying to integrate. But we are speaking about many years, and again, we have to pay our bills every month. So it's important to keep doing things in order to promote the sector, independent of US space.
And David, from the emergency point of view, that the BACO is focused, how do you see US space? Do you think US space will be also applying in emergency? It will help?
I think so. I agree with everyone, but I would like to highlight that the other side of the airspace, which is manned aircraft, they will be there. So, and we have a problem right now with UAVs because we fly our helicopters at very low levels, firefighting and things like that, emergency services. And we have the risk to find someone flying there. And to have some solution to provide us the information that someone is flying there is key for integrating both manned and unmanned aircrafts. But I agree with all of you. This will not happen in the next months. In the next, I don't know how much time we need for this to happen. But I think we need some interim solutions to start operating while this new technology and new space provides very interesting services. While this sits and gets the details that we need. It's kind of this will be very useful, but we need to test it to adjust it to our needs and to adjust it to the airspace also. So I think this will be several years from now.
I hope not so much, but I also agree it's not going to be next month. But so very interesting. Since in the meanwhile that we are waiting for US space, and David, maybe you can start. So from your company, have you identified any technological industrial development that we comment a little bit, communications, detect and avoid? So from your opinion, what are the key industrial or technological elements that could be that could facilitate these BVLOS operations, with US?
Well, I think I already mentioned the communications side and the detect and avoid technology, which I think they are critical, not only because you need it when you are flying, but also because the regulation asks you to have those technologies. One problem we have now with the regulation, and I agree with, I don't know, Artec, I think, the regulation is not a problem. It's the guide we need to follow to ensure that the operation is safe. Perhaps the regulation is not completely developed, and we need to develop it more, to have more requirements and to have means of compliance. But we need to follow that road. But in any case, the detect and avoid is key for us, and also the technology, perhaps not US space, but technologies that provide information to the operator of how the airspace is working. They will integrate in US space in some time, but you need that information. You need to know exactly where your UAV is flying and where are other UAVs flying around. To solve the problem that right now, I don't know if you have flown anything without segregated airspace yet, but it's kind of impossible or difficult, very difficult, and that's the key. I think you right now you cannot segregate the airspace today for tomorrow, and we can't fight a fire if we need to wait for 2 weeks. That's a problem.
Yeah. Thank you very much, Carlos.
So yeah, no much debate in this roundtable because I fully agree with you. Regarding to highlight something in our case, I would say the satellite communications solutions such as Starlink. We think that they are going to be game changer in the sector. Right now, satellite communications for drone are extremely expensive, and we are speaking about a system that costs, I think, 100 euros, and per month is like 100 euros. So right now it's too heavy and it has other conditions that it doesn't make it is not the best solution for the for the sector, but in a couple of years, we think that this is going to change, and this is going to be a game changer in the sector. To have a cheap and reliable communication for drones all over the world right now is going to be completely different picture. So that is going to be to change the sector, and for sure detect and avoid. And we fly very low level, so there are other solutions that the EASA is pushing that you don't need a detect and avoid. But yeah, in most operations that you are not flying so close to the ground, yeah, you need something like that. So we fully agree with that too.
So Carlos, just to so you think the satellite-based solution will be more appropriate for BVLOS than, for example, cell phone-based infrastructure?
I don't know if you have been in the field or in the middle of nowhere, but our experience is that there are not a lot of communication. And more than that, it's not guaranteed. So we haven't found a telecommunication operator that guarantees that in an area you have communication. So just to go to the authority and say, okay, we are going to fly in this area, but we are not sure if we are going to have a communication. We don't see that happen.
Okay, thank you very much. So, Rafael?
Yes, I want to mention, and sorry for the previous roundtable, that now the focus is on the aerial taxis. There are big players, as you can check here in this room, but this is not the only operation that we are going to perform. So we are not only focused on populated areas in big cities. There are a lot of remote regions, rural areas, coastal operations, and we have to face problems like Carlos mentioned related to coverage of the communications. Up to now, there is no solutions. We have some 5G items to give this coverage, satellite solutions, but we have to pay for them. So there is a lot of effort in these rotary wings over populated areas, but we have to think, in my opinion, for the whole picture. So for sure, BVLOS operations are more than these aerial taxis, and I think that we have to have this in mind to solve the whole problem, not this specific one.
Yeah, no, I fully agree, and especially for the specific category operations, I think that partially populated area and rural area are much better suitable. I mean, you can add a lot of value. You can improve the life of the citizens in those areas in an important way with, I would say, control risk, Maybe for the certified category, you can go directly to the urban areas, but for the specific, I fully agree that it's good to also push, in the rural areas applications. So, Kenneth, please.
General agreement with my colleagues here on the panel. All I'd like to add is this. I mentioned before ground-based solutions for connectivity. Of course, that doesn't apply in oceanic areas, so obviously you need to fly over the ground. But irrespective whether I believe we should have better solutions. What do I mean by better? What I mean by better is not only higher bandwidth, because to be honest, that's not the most important from my point of view. It is the latency. And why is that? The latency, it's not to do with the controllability of the drone itself, but the higher the latency, the larger the safety buffer, and of course the more difficult to get the necessary authorizations to fly in an airspace that is used by other players. So of course this connectivity will play a role where we can fly and where we can't fly, I would say.
Thank you, very interesting. So Javier?
Well, I agree with my colleagues. I will try to contribute with another point of view. Many times we are thinking about only flight, but also we can obtain requirements from the mission. In this case, for example, in our program, we need to collect in situ data to promote response to biodiversity use cases. So in that sense, the accuracy and the integrity of the position in that we obtain from the platform that they can correlate with the data is very important for us, no? So in that sense, in the development of hybridization of different sensors to obtain this information, GNSS, S-bus, inertial, 5G, LIDAR, and other sensor can contribute to obtain a very good performance for our mission. And by the other side, now we are living the digitalization process in multiple areas, and cybersecurity is an important component that we have to take into account when we are speaking about BVLOS operation, no? Because in the end, we need to provide enough confidence for end user and citizens. Also, we are flying very far from populated areas, no? Finally, respect to communication, obviously, we have to obtain reliable communications to keep a proper link between ground stations and the platform, and maybe in the future we can use a high altitude platform to integrate a communication set that contribute in these remote areas or far from populated areas to provide these services, and maybe cheaper than data satellite communication, no?
No, that's very interesting. Also, the use of hubs in order to provide coverage of large areas. So also, I think, I don't know if everybody is aware, but the current regulation in Europe allows fully autonomous operation under the specific category. Actually, the JARUS is working on PADR on autonomous flights. So this is something that is a possibility. The regulation allows it only in the specific category, but we have this option there. So how are you considering that this fully autonomous operation, BVLOS, will be possible in the near future? And if not, what do you think could be the main issue that make it happen or not happen? So, Javier, you want?
Well, maybe we trust in the technology evolution to perform this kind of operation. But obviously, many stakeholders and actors inside of this domain are pushing to introduce this kind of operation, application, and services that can facilitate this fully automated operation in the airspace. But obviously, we have to work hard in different areas, no, regulatory, technological. So it's possible, but we have to work very hard to find this object.
So Kenneth, you commented a little bit in your presentation, so please.
Indeed. Well, I would say there's no clear answer for the simple reason that we're talking about the specific category, right, for autonomous operations. And in the specific category, we've got the SORA process. And the SORA process, of course, calculates intrinsic air risk, intrinsic ground risk, and after taking into consideration all factors, you end up with a score, and effectively it allows you to fly or not. And this very much depends on your solution, whether it is the platform where you're flying, what I would say is that, at least my experience is that currently the regulation is very, very limiting, so it makes it extremely difficult for a realistic application to actually have obtained the necessary authorizations to be fully autonomous. Perhaps it is the first step. We hope that this will advance as time goes by. But right now it is quite constraining.
I think we are all waiting for the JARUS standard scenario, PDR. Let's see. Probably will be very limited, but I think it will be a very interesting, step forward.
Exactly.
Rafael?
Yes, again, it's not a problem of technology because the technology is here. I think we all agree. But again, for me, the problem is not the regulation, but how to tackle with. So again, I want to be repetitive with the three pillars. I think the first one is services. We are going to have available this dynamic and automated and digital information in I don't know, 2-3 years maybe. The second one is technology, and we have to focus in this detect and avoid problem, maybe working of this sensorization of small and mediums aerial platforms. For instance, as you know for sure, there are now an obligation of use a flight termination system for your platform, and this is something that is going to be developed in the next year with high maturity than now. And the third one is the procedure. So we have to work jointly to face these 3 pillars that I think is only a question of time, because the public sector is pushing forward. There are a lot of European initiatives, as you mentioned, of JARUS, of a welcome project that is going to give us results in, I don't know, 3 years. But we have to, for me, the challenge is to the interim until this moment arrives. So maybe in this interim, the regulation could be more flexible to let us state these business cases as a private companies and try to get these resources to arrive to this end goal of the situation for BBLO's flights.
Thank you. I would like to take also the opportunity also of join forces. So I don't know if you are aware, but Euroca is working standards for detect and avoid. Is working a set of standards that hopefully will make our life easier. So if you are interested, please join Working Group 105, which is the one of UAS. Okay, I don't get paid by Euroca, but I am a member. So please, you can just go to the website and get some information. Carlos.
You don't get paid, but you should. So
yes.
So regarding the autonomous operations, I think that's why we are all here. At the end of the day, we all want to have autonomous operations of thousands of kilometers or hundreds. But the problem is the technology. So I take advantage that the night is here. So the technology, the US space is really critical, and for that we hope that you do it as soon as possible. No pressure. But yeah, that's key. At the end of the day, all the clients are looking at the numbers, and one of the biggest contributions to the cost of operation is to deploy the personnel, to have 2 or 3 or 4 people go into the field. So just reducing incrementally or enable remote operations. So we go step by step, not fully automated for the first time. Otherwise we go. Right now we are fully on the ground. Next step, remote operations, and then autonomous. I think that is the future, and that could be an approach. That's the way we are trying to tackle this problem, this challenge. The regulation is not a problem, but for us it's a challenge at least.
So, David.
We in Babcock started working on UAS, I'd say 10 years ago or something like that. And as soon as we could, we started our research center, which is on autonomous aircraft systems. So we are convinced that this is the key element to the solution. It's not a short-term solution, of course. And the other thing I would like to highlight is that I think autonomy is a functionality that is very related to safety, and safety in traditional aerospace industry is measured in terms of reliability. And in that sense, I think the main problem with this is to get a way to ensure that these autonomous systems cannot fail, or if they can fail, you have kind of a ratio of failure, which is the way to measure things and the way to ensure that you are operating in a reliable manner and in a viable economic manner, because you don't need to face many problems, or you don't need to replace a lot of UAVs, which is good for you. So I think that's a very important point, and in that sense, I agree with Kenneth. In your presentation, you explained your roadmap to certification. I think this is the way we should go. Perhaps with the help of EASA and the procedures, which are providing ways to pack and facilitate how to measure those failures in a specific category and things like that. But the base is this. So we need to ensure that autonomous solutions and technologies can be measured in terms of reliability.
Okay. Thank you. I would like to thank all of you for very interesting, comments and discussions. I think now it's a moment for a few questions. So I don't know if someone from the audience would like to ask questions to our panelists. Over there. Thank you. No. The mic is not working. 1 second. No? You can talk loud, maybe.
Okay, I would like to talk louder.
Sorry.
No worries. Well, thank you very much to Antidio and all the speakers. I think it's been a very interesting roundtable. I think you have addressed a lot of interesting topics, but I'm a bit surprised about some comments. I have 2 questions, in fact. One is, how do you address to manage separation with regard to a non-conspicuous manned aircraft flying by your drone in BVLOS operation? What ability do you have to know the position of this manned aircraft? And in this sense, U-space or something similar be essential, because you've been a bit shy about the request to implement U-space, in my opinion. And related to this, which is the advantage of having nowadays a pilot when you only know the position of the drone, but you don't know anything else on your surroundings? So why don't you implement autonomous operation? Because I don't understand the benefit of doing this with a remote pilot when you don't know anything about what has happened in your surrounding.
Wants to? Carlos, you want to start? Yeah, go.
So, in my modest opinion, why do you want the pilot right now? Because she or he can push the kill switch. At the end of the day, that's I would say that is the reason right now. When everything goes okay, but if not, you have to have someone who handles the situation. So right now, that's our reason, at least.
Yeah. Also, you are completely right. The problem is to know what's happening around you, and you are flying beyond visual line of sight. You need to have that information, and that's the main problem today. We right now, I think, only have the option to fly under a segregated airspace. So nobody will be there, and if someone is there, well, bad for them. Yeah. but that's the main problem. That's the main problem to solve, and I think US space will help to solve that problem, and the other technologies we have talked about.
Just to complement I think you're totally right. Right now, the BVLOS operation are in a segregated space, but you can obtain this segregation in different ways. Like, for example, flying very close to infrastructure. So it's like, no, if there is an aircraft there, the problem is not the UAV. There are other problems because you are so close to the ground or so close to a building that you can estimate that this is a segregated space, even though officially has not been segregated. But at the end effector is the same. Yeah.
Just to add regarding the comment on conspicuity. In my opinion, and it is purely my opinion, if we want to move forward in U-space and integration of drones into airspace, I think the requirement for every flying vehicle, whatever it is, to have an ADS-B transmitter, I think needs to be enforced. Because if we're talking about detect and avoid technology, I'm not seeing small drones having a primary radar installed, right? So it has to be a collaborative approach, and with ADS-B transmitters nowadays, it's a simple solution. It's a low cost and also low weight solution, And I think that would provide the situational awareness that is required. Of course, if there's anything in the airspace that does not have a transponder, but that's clearly something is wrong, and that's not the operator that's needs to realize. That's why there are traffic services, there are military services that have the necessary primary radars in case something is wrong. But as a normal operation, I would say everyone needs to be conspicuous.
Yeah, I agree. 66 regulation is a small step forward, but not enough. You want to complement?
Just to complement very quickly, for sure the transponder will be part of the solution, but we will find birds, parachutes, paragliding. So again, the technology of detect and avoid must be in place. This situational awareness is made of different elements. There is not only one solution for face this problem.
Yeah,
maybe also we have to ask as myself how we can perform or actuate in these cases, no? When you don't have under control the surroundings, or you have non-collaborative elements around you, there must be a clear definition of the operational or of the reaction that you have to take in this in case of these incidents. No.
Yeah, very interesting. Okay, I think it was one more question.
Yep. Can you listen me?
Yeah. Go.
Okay, so when you discussed before about the communication means, and all of you mark the relevance of it, and you always spoke of communication as something external. So 5G, satellite, another ground base. Have you ever think of using the vehicles, in fact, as part and vehicle-to-vehicle communication as a solution to this coverage problem, as a solution to development mesh networks through the vehicles that can solve the extensive use of infrastructure we need today?
Yes, we have. In our solution, this is a solution under development, but we have that capability right now. We have not tested yet because we need to fly 2 or 3 UAVs at the same time, and it's not easy to have an authorization for that. But the solution is there, and we hope to be able to use it in. Mainly, we need it for offshore operations. That's our main point for that kind of solution. But we are thinking about that, yes.
One else. Yeah.
Yes, we have tested our TARSIS as a communication relay, some trials, but for me it's just an interim solution because as service providers we are not a telco provider. So for me, it's the same as your iPhone and your telco provider or supplier. So for me, are different businesses. For sure, you can use your UAS as a communication relay, but probably military applications or this kind of specific applications. But in a nominal operation, I think that we will use the existing infrastructure. But this is only my opinion.
And maybe we need to think about liability when you try to perform a new service. No, in case of any problem or incident, if you are contribute to a communication network, in the end you have also to guarantee these services with service level. So this is maybe another point of view that you can consider.
So I would like to thanks again to the participants. It was very interesting. So I think they deserve an applause. Please, if you have any pending questions during the lunch, feel free to get close to one of them and ask them freely. Okay, now let's go to the next keynote.
Se la pongo aquí. Well, everyone, thank you for staying until now. Okay. Hi, can you hear me? Yes, perfect. So, hi everyone, my name is Enrique Ventas. I'm US R&D Manager in ITG, and you will see me a few times more today. But I'm here to welcome our next and last speaker of the morning, Mr. Antonio Surdos, who comes from Cranfield University and is the head of the Center of Autonomous and Cyber Physical System and Director of Research, School of Aerospace, Transport and Manufacturing. So, welcome, the floor is yours. You have here still water if you need it.
Oh, that's fine. Thank you very much for inviting me here, and thanks Adidio for going through a few times the slides until we come to something that is in 2 digits and 3 digits. I will try to cover, I don't know how many of you know Cranfield. We are in UK, and we are a small university focused in aerospace and aviation. We have our own airport, and we have the flexibility to train to test some of the flights there. What I will try to capture here, and I think that was the main interactions I had with the DDO and moving and removing slides. It is I try to see what I could capture in these slides, and it is more or less I will give a vision of what we're doing at Cranfield with the national funding there. Try to see. Okay, this is come from UK Research and Innovations. This is the UK funding that created something that's called Future Flight Challenge in UK in order to address the urban air mobility, drones operations, airspace integrations, sub-regional aircrafts as well. And it was interesting because it came to 2 phases. One phase, it was more or less the pilot studies. So they found more projects and say, let's say what's possible. And the second ones, they start moving more on the trials and demonstrations. It is reasonably big funding. It is close to 200 million euros for that one. So they expect quite a lot at the end. And maybe they live on the expectations. The interesting thing for me, it is that it is the blue part that is started, because if you don't have that one, you cannot moving very much on the opening of their space. If you don't have communications, if you don't have navigation systems, you start having a problem. And this is something that we looked originally also from when we sit down with the UK government office, the Connected Place catapults, and we start looking what was called UTM Open Access, which is sort of like an architecture to address how UK will address the U-Space and the UTM. And that's what became there an issue that this is enabling technology that we haven't addressed very well. This is sort of like, I put it there just to see that it is similar with whatever we discuss here in Europe. It's similar with what we discuss in US and a lot. A very big visions that you can include on that one everything you would like to, from flexible, sustainable, interoperable systems, unified, and everything else you can think. This is the UK vision. It is as I say, it is not dissimilar with what it is in what we heard so far in these discussions. And they have put some examples. They say that we cannot start from everywhere. We need to having some particular use cases to start. Drone delivery, it was not surprising there, but they start looking airports and emergency services, intercity journeys, and all the other complexity increasing from as it goes into the programs. And they would like to see how we can having a unified way to address the airspace management for all of them and not in one of them. Again, as I said, you can find a lot of similarities what we do here. We looked when we have that once. We looked a few years back, and it was a program that you can see that there in Atlanta, and that was we had I think a student that was from Boeing at that time doing the studies in UK, and he brought all the data from there, and we tried to see, okay, this is how busy it is an airport as big as the airport of Atlanta. How can we start putting their drones in urban mobility? What things we need to changing? Is it that time, it was a couple of years ago, if we don't changing the sense and avoid systems, if we don't improving the navigation systems, can we actually add there more traffic? Will be possible, and what need to be changed? And that start came. Similarly, we did with connected place catapults for low altitude urban airspace, and we found the similar problems. And that means that the things that we discussed in the morning about communication, surveillance, navigations, it was problems that is not solved sufficiently for this kind of applications. And that's what. And then we went back to the connected place catapult in UK, which is the mobility R&D office of the government. Came back and say, let's do a small simulation studies. It is not qualitative, but it gives some quantifications of the problems we're having, and say, okay, let's go there. I don't know if that's one it is. Maybe. Okay, let's go around Cranfield Airport and find all the possible areas that we can have in vertiports. And that's looking hobby areas from aircrafts. We're looking small recreation areas that they are more or less ready to put something there. And let's start looking. And we're having also the Cranfield Airport with its own traffic. And that's not a very high density airport. It is a low density airport, but let's try to see how many flights we can having. And we know what is the airspace there, because we're having Luton Airport on the south, we have Cambridge Airport on the west, we have the Coventry and Midland airports on the north. So we're having other traffic going around on the airspace, and try to see what we can do around that one, and see what it is the problems we're having. And there is different traffic, and that's just simulations. And we see how many conflicts we need to solve at each time, and what we can do if we don't change anything. And we go to the easy solutions. Don't start, delay, hovering around, plan the route in order to take longer time. And we can see the number of conflicts and the solutions we found. Not what we would like to have, but it is just highlighting in an area that it is not London, it is not Manchester, that the problems that we're having and the problems that we need to find solutions on that ones. So, and we do see that the higher we go, and we didn't look in very many numbers of UAVs. I mean, if you're looking about 10, 20 sites around, the 50 UAVs is not very high number, and the 100 is still not very high around, because it is a big area of UK. So it had about 6 or 7 potential areas for vertiports that we simulated, and an airport. So it is not. It is you expect much more traffic than that, and so we still had the issues. We tried to see that once. And then we started, and because when we play around, the first problem that came to us, it is the navigations. If you're having more precision on the navigations, then everything can come closer. So you're reducing the uncertainty around the positioning, so you can stack more vehicles. And we try to start seeing what we can do that once. And we started with the problem, of course, because we working with the UK Space Agency in UK and the Royal Institute of Navigation in UK, and say, okay, if we're moving in an areas, in urban, is GNSS give us both the quality that we want, both on precisions and without latencies that we have. And of course, we're working with a company, I don't know if you are aware of that one, it's called Sparent. It can emulate the whole signals from satellites, from quality of services, from spoofing, jamming, and in urban and non-urban areas. So we took that ones and we start seeing where we're having problems. And we're having a lot of shortage of good quality GNSS-based navigations in a lot of urban areas in UK. So that becomes the first problem that we had realized and we need to solve. And that means that we did the same thing from the airport as well. And we find the similar problems, that a lot of things that you're moving around the airport, especially near to the buildings, terminals, and everything else, you start having similar problems. And but you start saying that you start having alternative sources of navigations. And now you start saying, where do I using, how I combine them, how can I jump from one to another, and how can I trust that? And that's what we start looking. And we looked, and we started with a number of problems. And I think this is, you will excuse me, but it is a little random, the slides on the topics, because it is different test cases that we have done. And it was from different projects, so we try to put together. This was from all of them. It is in one way or another from the UK Research Innovations, because even the UK Space Agency, it is part of a UKRI, so this is the larger body that funds. They say us in the beginning how we can fly medical drones. The medical drones that we had the problem, it is that it is between two hospitals. It was the Bedford, Luton, and then we did also the Milton Keynes. And this is within the cities. So they would like, first of all, to looking how we can do that once and try to find not only detect and avoid, but also the precision of the navigations around. And you split in two things. One of them, it is after you take off and you leave the city to go to the next city, which is one of the problem. And then when you're coming near to the airport, because there you're going in an area that it is quite sensitive when you're going down, and you need to deliver in a very high precise, whatever it is the goods, in a box, in a very small box, for not everybody to having access to that ones. And we start looking all the different areas, the dangerous areas, because you're having any other traffic, you may having helicopters going there for emergency as well. So we try to see all the analysis around for how to land with safely on that one. Then we did the similar things, and we did within the city, we start looking what is the quality we're having, where do we having the black spots that we don't having navigation system, good GNSS signal. Knowing that one, it is half of the answer, because then you're having solutions either don't use flight paths that going through there, or be prepared that in these areas you need to go to signals opportunities or other navigation systems that it will compensate the loss of the GNSS for a little while. But you need to be prepared that what that is. And this is what we start looking again. If we're looking in the urban area, it is now you say that path planning, it is something everybody has done. Routing, it is not a difficult problem. But if in the routing you start putting now the GNSS and the navigation quality that you're having, you start to readdress the routing and say, look, if you want to having the GNSS quality of services, this is the routes that you need to take. If you don't want, then this is where you're having the black spots, and this is the areas that you need to be prepared that you're having an equivalent solutions to give you the navigations that you would like to. And then you start looking, the UTM, it is start revisiting and say, what kind of services you're having. One may be more expensive because if you're taking routes with the quality of services, may be longer and may cost in different ways. If you're going to the fastest, but you're going to the black spots, then you having the vehicle need to address in a different way because it might having different payloads to address these spots. And we start looking all the different scenarios in many different cities in emulations, and you can start seeing that how we can improve the GNSS. Then when we discussed then with the European Space Agency and the UK Space Agency for the joint programs they're having, and we work with Thales and Vodafone. Ocado is a supermarket in UK that does all the deliveries around. It is only online, and that's what they were looking. Thales provides all the surveillance in the airport as well at the moment, and one of the UTM service providers. And Vodafone it is giving the communication systems with the 5G, not only in the campus but also in the two cities that we are next to the campus. And we try to see. We created a big corridor. It was about 30-40 kilometers. If you're looking around, and it is what will happen, what will come near to the airport or a vertiport where you may having a radar around. What happens if you go further and you rely on 5G or other signal opportunities, and how do you go from one to another? And that was and that was supported by the CAA Innovation Sandbox, because the CAA wanted to see, is it possible to going, and what is the issue by going from one to another. Then we start, and we tested that there. We do the last flight trial for that one. I think it is not next week, the week after, to validate the different alternative PNT. Then we start looking more urban areas, and we start looking even lower high. And this one came with a discussion we had with the MK Council and again the CAA. Can we start looking the infrastructure of a smart city? And can that one give us the alternative navigations? In the smart city, you're having cameras, you're having radars, you're having LiDARs around, you're having 5G. Can you taking all these signals of opportunities, fuse them together and say, I don't mind if I have a gap or a black spot of GNSS, I having a plethora of other sensors that going around. And that's we start looking how we can fuse the signals going around. They do having other problems, however. The latencies that you're having from the infrastructure to the vehicle, it is another problem that you're having. The synchronizations, because the PNT, it is not only the position navigation, it's also the timing, and the synchronizations between the different resources that you're having, it is important, because if it is not synchronized, then you create more faults and errors in your system. And all of them we haven't tested because it was not an issue before, and we start evaluated. And we start then taking all the different sensors, putting them around, and start looking both in the campus and also in the MK Council, and try to see what kind of sensors they're having. We are in discussions with different providers of that ones, where it is located, how we can go. You cannot populate it all with LiDARs, all with cameras. You putting, if you exchange from one to another, and so on around. So it is a big problem on that ones, but it starts looking more the infrastructure. And again, that one, they will change the UTM, and that's what we discussed with Thalys, that is part of the project, that if we go on that way, then the UTM needs again to be revisited to start looking different ways that they will coming informations around, more data around that one. We did also, that's what I say, and of course, when you're coming near to the airports, the radars can taking off, and that's the easy part. But the problem is the radar having only a specific, and the airports are not populated everywhere as well. So you can do more without when you're coming near to the airport. But on a smart road, all the poles they are having sensors, not the same ones, different sensors, and we would like to see when the drones are flying, do we know exactly where it is, and can we that one? Yeah. Synchronizations, we already mentioned. This is another program we had, and that is a very big one, and especially how we can do without GNSS as well, timing. And that's the similar things. We're working with the national physics laboratories there in UK. They try to create a network of atomic clocks that they will start disseminating alternative timing in the different nodes, that they will disseminate the vertiports and airports in order to compensate the GNSS timing. Cransfield is one of the nodes for dissemination of time. This one we already mentioned, and I will not mention again. How in the same way on the PNT, how you're changing from one to another, it is the same problem on the communications. How can you going from 5G to 4G, from 4G to SATCOMs, and the way back? The quality that you're having, the vulnerabilities that you're having. And I will skip these ones. We have done also the things for the landing, and we have worked with other companies looking the whole country and where you can land. And this is at start now the larger projects. We're looking with the Thalys-led project how we can having both the interoperability on the communications and navigation systems in the UTM they had that ones in not in an urban area but from city to city, and we looked on that ones. We did with Project Rise that was from DroneCloud. DroneCloud is another UTM service provider, smaller one in UK, and we start looking how we can start, and it was also frequencies there and skyports, and we start looking interoperability of UTM service providers in the same area and how they can link with the skyports, which was the drone operators at the time, and we tested in airport. The Southwest, it was a project that it was around Bristol Airport, that led by Atkins, the big consortium that you can see there, and it was how you can connect a city with an airport. So it is what kind of communications you're having, what kind of position you're having, what kind of infrastructure you need to change on the airport to be able to do that once, how the city need to be changed to become smarter to accommodate the airport. And this was a study that it finished. It will continue in something else. The UASA program with Ancoga, it was about the security. The moment that you start going to 4G and 5G and terrestrial communications as well, you start opening vulnerabilities on cybersecurity through the communications. And that was the Ancoga, we start to say how we can looking ways to prevent that ones and make sure that that doesn't happen. The Fly to Plan, it was a big project. It was similar with Ancoga. Ancoga was the previous ones looking for drones and vulnerability on the communications. This one was looking for airlines, vertiports, airports like Heathrow, and what are you doing when you start opening the communications and when you start flying drones and urban air mobility in that airport, because you open the different communication channels, and we try to see if technologies like blockchain can look on that one. I will skip this. This is some testing done in sense and avoid systems, but and you can see how many drones that were flying there. It was 5 universities in a large program from UKRI for low TRL, and we went for a week in Wales, and they gave us the keys of the airport, and we did whatever we wanted, except the weather. And we try to test the different sense and avoid systems and navigation systems and every other. Taking into account that Antonio is continuously showing me the time. The current project I have started about a few months ago, and that's the previous one I saw from the future flight. It was the pilot study, so it was more or less simulations, and now we go to demonstrations that they started. The first one, it was come from the west, the southwest project that we're having, but became slightly bigger. Now we start looking if we're having connecting the City Airport in London, the Heathrow Airport in London, the Luton Airport in London, the Bristol Airport on the west, and we're having the vertical airspace, and we're having the skyports building their own vertiports in different locations, and through the way how we can integrate urban air mobility within from one city to another, from the vertiports to the airports, and the changes that needs to be taking place. In the positive thing, we're having NATS, including on these ones, and they start looking, changing on the airspace that it needs to be done to look this one. So it is not only the UTM, but also the air traffic managers of the country needs to be involved if you're going to that scale program. The second one, it was something that we thought that we didn't think that it would be successful, to be honest, but here we are, and now we pay the price. It was an idea that if we want to having drones integrated in a very high density environment, and Heathrow Airport cannot be more high density environment in UK, and you would like to having 3 elements there. You having the traffic management that it is working there. You need to having a UTM service provider if you want to fly in that ones. And you have to have a country UAS because it is Heathrow Airport, and you need to know that it has nothing wrong happens. So the question is how can you integrate it all 3 in a way that enables safe and legal activity of drones in the airport. And we are lucky that the airport, it is part of Heathrow, it is part of the consortium, it is sort of leading these ones. But this is the whole thing that it's coming. And I think it starts becoming, we revisiting, because you talk about use-based architectures, you're talking about open UTM, open access in UK. It has to be revisited if we're putting the country UAS inside that architecture. And we don't know, this is the work that we're doing now. We have more or less developed the architectures, and we try to see. Synchronization of the 3 systems, resources and feedback from all the sensors we're having around, it is a big issue. 2 smaller projects. The previous one, it is about 2 years project, about 10 million pounds each one of them. This one is 2 smaller, which about 2 million each, but the same. The blueprint, it's looking for smaller UTM service providers, but including the ones that will provide the infrastructure. So the sensors that you would like to put, alternative ADSB around ground-based ADSB in the cities, and so on. And we try to see if you're having more than one, because you're having Skydrone, you have Neuron, you're having Andra, you're having Drone Cloud. Collins Aerospace is also, it is part of that one. And they start looking interoperability. Can they all working together in the same area? How can you mix and match the services? And that is the questions. And the safe zone that we work, that is a very very niche projects because everybody talks about building vertiports everywhere. The microclimate and the weather around the vertiports, nobody have think about how that information will be collected, what would be influence the flight clearances of the platforms. So I start looking about the wind modeling and the weather around the vertiports rather than anywhere else, and how we can start integrating that one as an extra information to the UTM service provider. It doesn't have a UTM service provider, but it has the Cardiff Airport that gives us access to test all the models there. And I think I'm on time. Thanks a lot.
Okay, hello everyone. Well, first of all, I want to thank IMOV 3D because of for giving me the opportunity to talk this afternoon about the work we are developing in the Spanish CAA. So, well, I'm aware that my turn is after lunch, so I hope you don't get so asleep. But I hope too that you get some coffee, so it's okay. Is this working? Yes. Okay, so as you know, as you already know, we published recently, the last year in June, a plan for the implementation of the EU space. This plan was elaborated between us, the Spanish CAA, but also with the collaboration of our National Supervisory Authority, AESA, ENAIRE, our main air navigation service provider, and also in close collaboration with the Ministry of Defense. This plan, the main objectives is act as an enabler for the implementation of the EU space in Spain, and it is also a roadmap for the deployment of these new services. The plan set out 4 main objectives. The first one is airspace actions. Its objective is it is arranged into different lines of actions, and this line of actions it has entities responsible of its implementations, and it sets out also why, what, when, and how, and who are going to implement these objectives. So, well, the first one is the airspace actions, which I am in charge in my area in the airspace unit in the CAA. Then we have the implementation of the national service provision model. That I'm going to say that later, but mainly it sets out a centralized model that we have only one SIS provider. And the third objective is the deployment of the services itself. And the fourth one is the establishment of cooperation and collaboration with, another administrations mainly, but also the stakeholders and other ministries. From the regulator point of view, which is us, the CAA, the main topics or features that we are developing now, it is, first of all, establish a centralized service provision model, which includes, as already said, a single common information service provider. That's why we choose that option, because, the SIS provider, a single SIS provider, is a unique, trustworthy source of reference of information and process data. And also in these first stages reduces all the complexity for the whole system, the US space system. Then we have certifications task, but the competent authority for this for the certification and the supervision of the provision of the services and the services providers is AESA, or National Supervisory Authority. As you know, we were pending on the publication of the last versions or the last package of the AMC and GMs for the the regulation of the EU space. And well, they were published on December. So now the certification, and also because the entry into force of the regulation, it is now working. It is now working. So then for the aerospace part, which is our part, we created two main working groups, and these working groups are multi-level and involves many administrations, ministries, and also we want to involve some stakeholders, or many stakeholders. These two groups are one national working group for the implementation of the EU space that oversees and oversight the implementation of the PANDU. And we have implemented another working group, which is the US Geographical Zone Group, mainly for the airspace coordination, for the implementation of these geographical zones, but also the designation of the US space airspace, and support the strategic level of ASM, the airspace service management. So in these two working groups, we are collaborating also closely with the Ministry of Defense, because we understand that the airspace management and the airspace, well, the designation of the US space airspaces, it depends also in the military side, because as would you already know, the approval of these airspaces is a jointly decision with the Ministry of Defense. So that's because the importance of these national groups. And then we have to think also about the development of the US space charging scheme, because, well, now we are waiting for the conversation and the solutions that maybe is going to come from the SIS2+, but in some kind of moment, we don't know when exactly, maybe when the SIS2+ is, I don't know, resolved, or the conversation are dissolved, we have to think about this very huge, important topic also. And well, from the aerospace point of view, we are working now inside these working groups. What are we doing? So we are working now, we are working now in the coordination mechanisms, mostly, and we implemented a 3-level coordination system, because the US space regulation setups, and it is mandatory, this kind of coordination mechanisms, and you have to coordinate with local and regional authorities, or also the state authorities, and many stakeholders. So that is a huge task, and the resources are a few. So we had to think in a system that it works for us, but also that it works for gather all the information we need from these levels, and these administrations, local authorities, but also the stakeholders and the operators, and so on. So we arranged a 3-level coordination system. We already put in place the first one, which is this working group, the US Geographical Zone National Working Group. And we are working in this first level. It is a ministerial level, and we are working in the US space designation, first of all, and then also in the signing of the approval of the geographical zones. And in this working group is involved the Ministry of Defense. Then we are going to set up these second and 3 levels. The second level is formed by another ministerial departments and regional and local administrations. And then we have these 3 levels, which are implemented by these other identities and entities and stakeholders. So soon you are going to see published, because this portal, we are working in a coordination portal which is going to be published in the Ministry of Transport website. So these 3 levels of participation is going to be automated, or at least via online. We are not going to develop more working groups because that is huge. And we are going to try to communicate with the another 2 levels, with the 2nd and the 3 levels, through this portal. So now we are working in developing this portal. It is not published yet, but it is going to be published soon. And we are going to launch a series of surveys focused on these new 2 levels, the 2nd and the 3 level. And the main objective is to gather the information about U-space needs and also another kind of need, airspace needs regarding U-space. But also we are, once we, in the first level, maybe we decide to implement U-space airspaces in some kind of place, we are going to let the 2nd and the 3 level know through this portal. And the rest of the stakeholders and the administration and the other ministerial departments are going to make data observation about this U-space airspace designation through this portal also. So it is a 2-way communication, first like top-down communication with the information we want them to know, and a bottom-up approach with, these needs that are coming from this other administration of the stakeholders on everything regarding U-space, and we are going to treat this information in the first level group. So what, apart from this portal, the coordination mechanism portal, we are also currently doing another kind of task in the CAA. First of all, we are defining the criteria of the declaration of the designation of the U-space airspaces. That is something another states are doing. So we are doing it now. So we are also doing it now. And as you know, the regulation only sets up that the U-space airspace is going to be established for safety, security, privacy, and environmental reasons, but that is so open. So we need to know what is safety, what is security, what is privacy, and what is and environmental reasons. So we are thinking about it now. And then we are working in a procedure for the application or requesting these U-space airspaces, because, we are an administration and we need administrative procedures, so someone has to work on that. So now we are working also in this administrative process. So if you want to request a US geographical zone or a U-space airspace, you go through this administration process. So we are working on that too. And then we are working in actions focused on the dissemination of the U-space concept. We developed already a brochure that is going to be published in the Ministry of Transport website, but also we are going to disseminate this brochure to everyone that we know is interested in that, but it's going to be published in the website. And also we are doing a benchmarking with other countries. We are having now many bilateral meetings and meetings mainly, and interchange of information with our neighborhood countries like Portugal, Switzerland, France, and so on. So we know what they are doing, so we can base also our approach in what are doing the rest of the countries. And the next steps, it is mainly to put in place these coordination mechanisms, which is mandatory. Then we are working also in the airspace risk assessment. As you know, we need to do that to designate a US space airspace. And the next challenge we have, it is to designate the first US space airspace. So we are doing this now, and along with the certification and designation of the US space service providers and the common information service providers. So that is all the working we are doing regarding US space in the CAA. So we are going to keep on working on that, and thank you very much. If you have any question, I'm happy to respond. Thank you.
Thank you. So, yes, it works. So, Luc Anton from SKYS, the Belgium ANSP. Just one question about the publication of the use space, because you said that you use a portal to exchange with different actors and so on. But after, when it will be decided to publish the use space, do you have an idea where you will put the use space airspace in the AIP? Because we have this question, and then we want to exchange.
Yeah, well, yeah. Do you mean exactly we are going to what? Yeah, we are going to publish in what, in which part, which section of the AAP? Yeah, we have to discuss that too. Yeah, we don't think of that yet, but it is a very good question, because for the geographical zones, now in our new national regulation, which is not published yet, but is going to be, we only say that the US geographical zones are going to be in the AAP only when affects to the manned traffic, because otherwise it has no sense and is noisy in the AAP. But we don't know exactly what section. Maybe it is in the en route. Well, where you publish the other kind of airspace structures like TSA, TRA, dangerous areas, and 5.1, of the AAP. Maybe that is the place, but it is not established. Yeah.
Question? And do you have any time frame for the, let's say, for the first US space zones in Spain?
Well, we hope well, that is a tricky question, but we need, first, we need that the Common Information Service Provider and the US Space Service Provider is certified. Then they need a US Space airspace to operate, so they don't lose their certificate. So we are going to do this process in parallel. So maybe when the certification process is finished, we also are going to know where is going to be the first US space airspace and then be published. But we hope it is this year, but we don't know. It depends how the process goes. And also, as I said, you need, for the declaration of the US space airspace, you need to make an airspace risk assessment. And it is the first time we are doing that. So we need to see how that goes also, and if it's an easy or not easy process, complex process, so we'll see. But our objective, it is this year, but I'm not compromising here. It's all in YouTube. This. Yeah.
No, it's a really good question and a really good answer, to be honest. Something that we have been discussing a lot, because I think we need some temporary airspace to different tests.
Yeah.
We don't need at least a new space airspace, but maybe they need to act
and use space airspace able to manage.
Yes, also we are thinking about temporal US space airspaces, not because of that, because maybe we need this temporal phase in the beginning, but also because in the future there is needs that you need US space airspace in some point or in some region for a very specific kind of operations, or I don't know, and then you don't need it, so you can use that temporarily. And we are going to see what is best for the users of the airspace. So yeah, but to develop these tools. And I think, I don't know other countries, but I think this flexibility of the use of the airspace, like temporary, not permanent, and also permanent, etc. I don't know if it is in mind of the rest of the countries. I don't know the rest of the states, but I think that is a good option. Yeah, we are thinking of it, of course, for sure. Yeah. Yeah.
Because the hearing just after that, the demonstrators that are going now try to have another 3-year project is a deployment going to, and you will have a demonstration in Spain. So how is the coordination of that project?
Yeah, it is direct communication.
So you're part of the
no, but we are, ENAIRE, which it is part of this consortium. It is involved directly in these working groups and also in the PANDU. And we are, the US space airspaces that are going to be used in these demonstrators, we are analyzing that too in these national working groups, because maybe, we don't know, it can be real at some point, but we have to decide that.
Okay. Still, I think we can continue discussing with you space in the round table.
Thank you.
Thank you very much. Well, first, I want to thank Marina for the great presentation. Well, in part because she has done some spoilers that we are going to speak now, but at the end it was great to have the vision of the Spanish CAA on the discussion of the US space deployment progress. That is what is the discussion now. And why? Because I think US space is trending topic. Antidio mentioned before that he was surprised that US space didn't appear in the conversation before. For me, it's one of the pillars of what is going to be the evolution in the coming 2-3 years. Why? And why we are doing this now? First, because the US space regulation came into force just a few weeks ago. Then, at the end of December, just for have a great Christmas reading, the acceptable mean of compliance and the guidance material of EASA were published. And also, there is an end of cycle. The all CESAR projects, all R&D and very large demonstration initiative are now ending, and the new projects are going to start have already started. We are talking, we have representatives here of the 3 digital sky demonstration projects regarding USPs. And last but not least, I think now is the moment to answer the question to all the citizens. So, I try to make a compendium here of questions that people around the industry are now talking about it. Let's see, we have time to do so. And for that, I have my 4 panelists here. Farah Lu is project manager for Thales, and today is representing a You Welcome project. Luke Anton, UTN manager in Skies, and today representing Bardi project. Dr. Wasim Dergesh, who is representing IALU Air project, and comes from Ireland from the FMCI, Future Mobility Campus of Ireland. And not for a project, but we have also Daniel García Montabaro representing ENAIRE today, and he is the head of Drone Business Development Department in ENAIRE. And the first question is for you, Daniel. How is the deployment of U-Space going in Spain? What is ENAIRE doing to support this development?
Hello, everyone. Thank you for having ENAIRE here other year. And well, I think that the message is going to be, well, quite different from last year, and I think is positive. Well, Marina has put it very easy, because one of the things we are doing from not ENAIRE only, we are participating in under the Ministry of Transport framework in the PANDU, in the U-Space deployment, national deployment. And I think it's very positive, all the action that we are doing, because we have different objectives and different tasks, as Marina introduced, and I think it's very positive. It's one of the main things that ENAIRE is doing. Also, we are leading, or not leading exactly, but participating in many projects of U-Space. For instance, one of them is one of the DSDs that Faria is going to talk in order to coordinate the Spanish part. We are also participating in national work groups for regulations, and also from standards, international group standards like EuroCAE. So we're trying to be updated and to participate and to give support to different initiatives. Also, as today, we like to participate in the communication and dissemination part of U-Space is very, very important. For instance, tomorrow in ENAIRE, we are going to have a workshop with general aviation, and when one of the topics is going to be U-Space. And so it's very important to get them involved from these tasks that's in ENAIRE. We also hear the needs of operators and drone operators or taxi operators as much as we can, because they give you the vision of what is needed for U-Space, not only what is going to be provided, but also what is needed, and it's very important to hear that from the users. And of course, we are deploying the U-Space platform, the ENAIRE platform, the Common Information Service part, specifically as the main part for joining for the multi-USSP environment I want to have here in Spain from the very beginning. I think that it's something that is a challenge if you compare with other member states. And of course, also to deploy in this multi-environment USP, also the interface with authority users and entities like Air Force, etc. So,
to be honest, that's a lot. I don't envy you. Your agenda is crazy right now. But now it's in the moment for the project. So please tell me about your project, but in a nutshell, just 2 minutes. Explain why your project is different, and of course how it helps to bring U-Space closer. So Farah, you can start if you want. Then Luke and Wasim.
Hi, everyone. So the UWelcome project is helping to get your Europe-wide implementation of systems and procedures that will allow safe drone operations across Europe. The reason it's different and why it's important, because it's one of the first projects with the other 2 DSDs to actually implement at a large scale what was so far done only in laboratories or small scale. And by the end of the project, we expect to have implementation of infrastructure and procedures in operations. So we're not just talking about flight trials. At the end of the project, what will remain is services and infrastructure to allow real-life operations. So the ULCOM project itself represents quite an ambitious goal as well, because we're targeting the market uptake of U-Space services. And in order to do that, we need a strong team. So ULCOM is composed of 51 partners. We have industrials, we have national, international organizations, we have service providers, universities, R&D centers, startups even. So this is all quite diverse, and Eurocontrol is leading the project, as their goal is also to support harmonization and fertilization across Europe. So the project will take place around 3 years. So we actually kicked off in November last year. That was just 3 months ago. We're currently in the planning phase that will end next month. And then we move on to implementation. And we'll have implementation with multiple flight trials happening up to summer 2025. The project itself will end in October 2025 with the submission of recommendations for the Europe regulations. Concretely speaking, the work we're doing is to design the airspace, to develop the technological infrastructure and operational procedures in 15 regions and cities across France, Italy, and Spain, because we organized also around 3 clusters. So one in France, one in Italy, one in Spain, and each of these clusters will be responsible for the project in their own geographical area. So to go back to the question, why is it different and how it will bring us closer to the U-Space development, I would say that it's its level of ambition is quite high, and at the end of the 3 years, we won't end up with just results about trials and demonstrations. We will have real services deployed.
And that's the real value at the end, to bring closer use space through deployments. So let's see how in Ireland and in Belgium are doing. Luke, please.
So thank you. So I'm the representative and the coordinator of the Birdie project. The Birdie project is supposed to be deployed in Belgium, Belgium territory. And as for the ULCOM, we don't expect to be closer to the implementation, but to implement. And to implement the use space, and we have the ambition. I don't compromise me, because this is just an ambition. But we have the ambition as well, like Spain, to have the use space airspace this year. And the ambition is this summer. Very ambitious, because when we say implementation, and Marina talked about that, is that you have to talk about certification, you have to talk about operational solution. So, and operational solution, we expect to have all the people around the project, with IT developer, with drone operator, but also I call the administrative part, but it's very important. This is the implementation, because the implementation then join the operational, because you cannot be certified if you don't have all the procedures, operational procedures. So this is why within the Birdie project we will be really attached as well to develop procedures to do the risk assessment, because within the risk assessment you have to coordinate with a lot of actors to create, or not to create, to designate the geographical zone as a use space. But with new actors, so this is quite new for us. Even I come from the ATM world, but I don't do that. No? Normally, I just discuss with some airspace users, but not with local authorities, with police and these kind of things. Never. So this is something that we have to put in place. And to do so, we will have a staged approach. So we will start in a less complex airspace, because we will have one cluster at a time. Belgium is small. So we will have one cluster at a time, but the intention is to develop something, the procedures, and to be certified for a less complex, I cannot say easy area, but less complex area. And then to expand the way of working and the procedures to a more complex, and especially the control airspace at the end. So this is the way of working that we have in mind. And in parallel, of course, I'm the coordinator, I'm the representative of SKY, the ANSP. I worked in close cooperation with the Belgium CAA, Civil Aviation Authority, in order to prepare these kind of things, because in the Birdie project, of course, we prepare the procedures, but we are not, we don't have the decision, the final decision. So we need to be accompanied by the CAA. Otherwise, we will go nowhere. The publication in AIP, the procedures, the process, how to certificate the CISP, because SKY is already designated as a CISP for Belgium. So it's already done. Now we have to be certified. So, and this is a challenge, but maybe we will discuss then about that. So really, I believe that Birdie has this specificity that we will have a stepped approach, less complex area, and then to expand to a more complex situation, more complex environment.
Okay, that's good. I think that's one thing that in the WorldCon has also discussed, from less complexity to real environments. Have you taken a similar approach, Wasim?
Yeah, so I think it doesn't make sense to describe again the Elware project, because I think it's all the same project. So with three of us have the same ambition and plan. Belgium is small, Ireland is even smaller. But what we wanted to do is, so myself, I come from Future Mobility Campus Ireland. So in a sense, we're a test bed for mobility, right? So when we wanted to coordinate this project, we wanted, and we saw in it that it is going to be adding to the infrastructure and to the ecosystem to allow companies to straight away come and test. But as I said in previous presentations, between our the hub where we're going to do testing and the airport, we have two fences. You basically cross our fence, cross the road, and that's the fence of the airport. So I think it cannot be more complex than that. If you can do it close to an airport in a controlled airspace with a major international airport, I think you can do it anywhere else. So, and that's probably one of the main differentiators that we have in our project. We already have clients and operators that come and do tests and validate some stuff, but now they also are looking, oh, so you have a demonstrator. Now I will be able to start, foster, and accept developing from now use-based services as well as part of their aircraft or their operations and all of that.
That's good, because at the end, industry should be involved at all stages in the development and the deployment. Now, let's go to speak a bit about the airspace. Marina has introduced about how Spain will manage airspace. So I want to know the opinion of Daniel and Far about this. Daniel, don't worry, we don't tell Marina what you say. So my question is, how should we decide which location are use-based zone material, and who should decide it? Governments, civil aviation authorities, local authorities, industry? Please.
Well, the demand, I think it's clear that has to be from the industry, from the local authorities, because it has to be involved. So it's very important that the demanding, that of course, as I repeat, it comes from the, I think, from the industry. You need the local authorities to support that kind of operation or that future business. And together to do the, well, Marina has explained how is the mechanism for asking or the different levels of, in order to ask for airspace to become U-space. And of course, the assessment or the approval has to be done by what is said in Spain, that is this high-level governmental space group, okay, CIDETMA, that is in Spain, and this is, and from CIDETMA there is these groups related to U-space, these work groups related to U-space and US zones. So that is more or less the answer. You need you have a proposal for the industry and I think and local authorities together. I think it has to be a business background also. And if it's not a business background, that is for other needs like security, environmental, maybe the governmental or other local authority has to be, the authorities to do the request. But if it's a background or a business background behind, I think it's going to be the industry with local authority to push on that. And one thing is important. The easier is the U-space operation, the easier would become U-space volume. So
yeah, that's totally true. In your case, Farah, what do you think?
I will try not to contradict Danielle because we're working on the same project.
You can do it.
I won't. I will try to complete with a couple of examples of what's happening in the clusters in You Welcome. First of all, in the French cluster that I'm currently leading, just to tell you how we decided of the location of the operational site. We discussed with the city of Saint-Quentin-en-Yvelines, who expressed interest in the project. They wanted to design, to develop a new test center in their city to bring, more business and more people and everything. And so they started to produce a list of possible locations that they thought would be interesting, but they had no knowledge whatsoever about airspace management. So they provided that list, and then the industrial, Thales in this case, so my team, performed a risk analysis of all these locations, so air risk and ground risk analysis. We eliminated, of course, many of these locations, and when with the locations remaining in that list, we went to the Civil Aviation Authority to seek advice and recommendation, also to make sure that we did comply with the constraints and regulation. So in this example, I see 3 entities working together and everyone benefiting from this. I will tell you also about the corridors that we are opening in France. There's another entity coming into the discussion because the corridors will cross several cities. So we decided to include also all the mayors in this discussion and analysis, also to help them and give them the material to defend the project and build social acceptance, because they will be the first contact with the people when we'll be flying drones, in the cities. And this was very well perceived because we helped them get some knowledge, basic knowledge, but still, so it's all a collaborative approach. So that's what's happening in France. I'll give you an example of the Italian cluster. They have actually a double approach because according to the site, they have several sites for trials in Italy. There's the top-down approach. So in this example, you have the Department of Environment in a district that would like to perform surveillance mission to prevent illegal dumping. And so they need the creation of U-space airspace. And then once the airspace is created, they will attract UAS operators to perform flights. And then in another location, there's another use case with another purpose. And so this time the need comes from the operators themselves. So it's a bottom-up approach. The operators need to perform flights for the transport of medical parcels from a hospital on the coastline to another hospital in an island. So in the same country, you have 2 different approaches. One is top-down and the other is bottom-up. In France, it's more global. So to answer the question of how to select, how to choose a location, I think it cannot be by a single entity, definitely. It needs to be global, pragmatic, based on also risk analysis, because we're talking about airspace, so safety first at all costs. And yeah.
Yeah, the good point is there is no unique solution to do so. There is different ways to do it, and each city or each region needs to choose one. And that's helped me to do the next questions. At the end, we have to speak about the AMC and the guidance material, and they will have a lot of challenges. Look, Daniel, what are the challenges that you see to implement U-space tools regarding the AMC and the guidance material? Look, you can start.
Yes, as you said, everything is a challenge in U-space. No, we have to choose. So, and if I have to choose, I should say that the certification is a big challenge. And this is why, for instance, Marina said that also is that in Belgium we have the idea, the less complex airspace, to decide on the airspace without assessing if it is really needed or something, to consider this airspace as a use space, but temporarily. We discuss with the CA to do that in order, again, to do the procedures and then to use the procedures to improve the system and so on. But for the certification, so why it is really a challenge, this one, because behind this word certification, you have a lot of things. You have a lot of things, and especially for the CISP and maybe for the USSP. For the CISP, because in the Birdie project and in Belgium, it will be SKIES. So SKIES, we are used to manage the notion of quality management, cyber security, and this kind of thing. So this one, I can do that. But for USSP, it could be very different, because it's a new function, a new company, and then maybe it could be different. It could be complicated. But then, again, behind the certification of the CISP, you have something new, which is the business plan. And then, again, this is completely a subject by its own, but the business plan, what is the economical sustainability of this model? We don't know. So we have to imagine, even if I am an ASP, so I know RP3 and so on, but it's completely outside and it's another world. We also have to talk about IT tools, supporting tools. So we want to use some result from previous project in which SKIES were involved, and we have a partner for that. But we have also to integrate a new requirement and this kind of thing. So sometimes not well defined in the AMC guidance material, but it's always the case when you have a new regulation.
Yeah,
it's a chance, but it's also a challenge. It's a chance. So it's the certification, and to have this certification, I believe that we will have, because it's quite new, we will have to do something that is really also new for the Civil Aviation Authority, is to have an iterative communication with the CA, considering the airspace or the geographical zone that we want to designate as a use space, as a first one, as a definition of the procedures and so on. So it will not be in the future like this, but at least for this first one, it will be really a new way of working with the CA that we will have to put in place. Yes. And this is something that I work on with the CA outside Birdie, with the Civil Aviation Authority, in order really to ensure that the certification is fit for purpose for this first use space, not for all the use spaces, all the situation, all the environment. No, as I said at the beginning, is that for me, it's really a stepped approach, and then start with a less complex, and then improve the system after accumulation of knowledge and
I think, in my opinion, the main challenge is not the certification process, it's the learning process to certificate. So I don't know if you share the view or you have another challenge, Daniel?
No, I think that Luke has elaborated very well. I subscribe all the answer that he has done. Last year, I said that the challenge was the gaps that was in the AMCs and guidance material, because we had only a drafting. Now they have been published. They've been published 1 month earlier to get into force the 26th of January. So.
Plenty of time.
Yes, plenty of time. Yes. And the problem, for instance, is that we started to deploy the system in summer 2021, and we filled some gaps, and now we feel them wrong. So we had to do some adjustment now, and it's not a problem because we have done some. The way is done in some way now, so we don't have to start from scratch, but we have to adjust. That's one of the main challenges. Also, the airspace risks assessment is something that is a challenge that is in the AMCs, but there is lack of details, and that's the reason we have in the group, in the national group, the help of Eurocontrol in order to start aerospace risk assessment from US space. And there are other things, technical things, I'm not going to get into details, but they are very new in the AMCs, and it's totally new, and especially for the USSP. For the USSP, from a technical point of view, something that was related to the operator to be the responsible now, some things now go to the USSP part, so from technical point of view, a sanctification point of view, maybe it's going to be also a challenge.
Okay, but then there's another question that I want for Wasim and Farah. Do you think one size fits all? We need to apply the same requirements to all the different USPs, whether they are deployed in a city or on a cornfield? Wasim, you can start.
I think the answer, the question answers itself by itself. Like there is no one size fits all in any new solution. So it's all about try and see what works. But obviously from the types of airspace you're talking about, so you cannot have the same level of validation and implementation of a use space close to an airport to an area where you just go off the coast and then fly over maritime areas. So it's obviously there should be a lot of leeway in creating this set of requirements for USSP implementations in certain areas. So there is that leeway, because I think most of the requirements, they would come from ANSPs, and correct me if I'm wrong, Luke, but even though there are requirements coming from there, but also that comes from a learning from how to operate and how the operators will work. But I think the main challenge really for USSPs and the big requirement will be the interoperability aspect, because especially in highly populated areas, so you might not give the USSP service to just one operator. You might segment and create a lot of spaces managed by separate ones, but you might also have overlaps because you need to get a redundancy, even though it's not a redundancy on the aircraft, but there is a redundancy on the operating system or maybe the information system, which is really crucial, especially in controlled airspace, to make sure that, you got the information timely and with a potential redundancy. It's one of the challenges that we will be looking at in our project, but we're going to have a commercial USSP implementation, our own local, let's say, open source implementation for that, as well as Collins Aerospace as one of our partners would be also implementing their own and adding another simulator to try to mimic cyber issues, cyber attacks here and there, because that's also another challenge to look at. And there, it's drone operators, especially early stage ones, they will always look for a space where there's no restrictions. Let me just go and do my hover testing without anyone looking at me. So they will go into remote areas where the risk is very minimal. But at some stage, even those types of tests, they need to be declared somehow, and there should be visibility of those activities, and USpace will help make sure that this is available. Farah? Don't be afraid of contradicting me.
No, I'm afraid of not having anything left to say. Actually, you've said it all. Thank you, Wasim. That reduces quite considerably my answer. No, I fully agree, and I think we're aligned here. I don't know what to add, except maybe, so another example of a ULCOM project, just looking at the Spanish cluster, we have several locations, very different, with very different use cases as well. So, for example, there's the objective to fly an air taxi over a river in Seville, emergency deliveries in Valencia, Zaragoza, Canary Islands. You have surveillance missions. So it's really hard to say that one requirement would fit all these at the same time. As you said, the answer is in the question itself. Now, we can also bear in mind two aspects that are quite important to us and more very concrete in the starting of this project. There's the risk aspects. So obviously we will start, as you said, not in an environment that's not really easy, but less complex, and that would present a lower risk for the operations. So we could say that that's a good, for example, the non-urban environment, because of its less complex structure and population, that's a good way to start. But then, depending on how close you are to a controlled airspace, maybe you will get a higher air risk. So really, it depends on the location, and really keeping in mind this risk aspect. The other thing is the infrastructure. In an urban environment, we could benefit from existing infrastructure. We could get probably better coverage, whereas in the non-urban environment, you would need to implement to install those new equipment, and depending on the location that you're trying to cover, that could represent quite a significant investment. But that could also lead to new ideas and new solutions. So I would say, as long as there's a need, there's a solution. But really, what we observe is that often it's not the same. We cannot apply the same solution, same requirement from one environment to another, and that's the real challenge.
Yeah, fully agree with that at the end.
Yeah. So if you don't mind, and I believe there will be another challenge, especially for your project, that if you're going to try to do cross-jurisdictions flights, and then you have an air taxi flying starting from Italy and landing in France, so how do you see like USSVs will have to?
You gave the answer already. Interoperability.
Yeah,
that's the main.
But from your project, are you looking at that?
Interoperability.
From our project, so I think there's a use case here for a flight to be tested with to check the interoperability between Spanish and Italian clusters. Maybe Daniel, you want to say a couple of words because you're involved directly in this?
Yes, we have a specific task between Spain and Italy to test the USSP from one country in the other country.
We are not crossing borders with a drone. We are directly moving the USP from one side to another.
Yeah, alright.
And that's another challenge, skill and aviation. And for me, you have said two key words: redundancy and interoperability.
Yeah.
When you read all aviation material, you're always going to find these two words. And another thing that is infrastructure. That's my next question. Farah has already introduced part of that. What are the infrastructure challenges? Farah, you can start now that you have opened the box of that. And look, you can continue.
Okay, I'll be happy to. So in order to deploy safe drone routine operations, we are faced with two fundamental risks. The first one is the air situation awareness, what we call surveillance. I think it was mentioned this morning. We need to inform the remote pilots of drone operators of manned aviation traffic at all time. And there's the detect and avoid aspect, of course, that's quite important. The second risk is the loss of communication, what we call the C2 link. We need to make sure that there's the remote pilot keeps control of his UAV and mission at all time. So to address those two fundamental risks, we believe that there are three layers of infrastructure. The first one is the ground and physical infrastructure. So we will need radars, antennas, I think ADSB was mentioned, surveillance sensors, control and command radios, etc. Then once you have that, there's the second layer, which is the software infrastructure with digital tools to submit mission requests, to manage the airspace, the emissions authorizations, the trackers as well on the drones, the health monitoring of your system to make sure that the services are live at all time. And then there's the third and final layers, which is the UAS services. I can provide a list, but I don't think that's the point here. The list could change, of course, depending on the location and how close you are to a controlled airspace, because as I mentioned, we could benefit from existing infrastructure. But do these infrastructure already cover, are sufficient to cover the use space airspace that you just created? And are they relevant for drones? That's all part of what we are trying to do here.
Okay, that's grand. I don't know if Luke, you have the same opinion. Just one thing, we are running out of time. I only have time for one question, and I will ask the public to do another question that I have. But that's perfect. You can
I would try to be very short. No, I fully agree regarding the requirement, the technical requirement, and all these kind of things. But I believe that for the infrastructure, we have also to consider uncontrolled and controlled airspace, because it's not exactly the same. For controlled airspace, for instance, you will have the ATSP, air traffic service provider infrastructure, and then for the man aviation, and all the information from the man aviation will come from the ATSP provided to USSP, and then the USSP will only have to deploy some system to collect remote identification and these kind of things. So it's not easy, but it is limited, let me say. Yeah. In uncontrolled airspace, it's a little bit different, because you will not have the information for the man aviation, except if the radar coverage is there, and then the ATSP can provide, but it's not for the purpose. Yeah. We don't use the radar to see uncontrolled airspace, because this is not our responsibility first. But for the even for the USSP, they have to deploy some system to collect information for the e-conspicuity of the aircraft, and then you have different solutions. You have ADSB, you have transponder, you have a mobile phone system, and so on. And the other thing is that what nobody talked about, at least in the EMC guidance material, is that when you are a USSP and you have an information traffic to provide traffic information service, you need a kind of depth. I mean that before the threat, you have to detect the aircraft, and then to have time to provide information, not with a guy, but even with automation. And this is something that we don't know for the moment, because it depends on the speed of the aircraft, it depends on the environment, and so on. So this part, I believe, could be very difficult. Maybe not in Belgium. Not in Belgium, we are very flat. But I think about mountains or something like that. So it can be.
I think we have the situation in Spain. So not to conclude the panel, one last question and another one for the public. Daniel was saying, what are the next steps for deploying U-Space? Daniel, you can start.
Well, I think that these 3 DSD projects are a very good example of how to perform as is named the project that has fast track, that is from the TRL low to or medium to a pre-deployment. I think they are a good example for having a real operational deployment with the support at the same time of the national authorities in order to address all the certification process, the airspace risk assessment, etc. And the most important part is to continue working in social acceptance, because if there is no that, we can have the technical deployment certification, but the real operational deployment is to be ready for the social acceptance incidents that will come and to be prepared for that.
Yeah, Larry, in your case?
Yeah, so I think exactly what Daniel was saying, like this is kind of a starting point. There's already a lot of effort coming from EASA in terms of regulation recommendations. There's a lot of effort from all the local national ANSPs as well. They're doing all of their kind of due diligence to make sure how they plan the implementation of U-Space in their kind of countries. But the thing, I think it's one of the questions that I asked earlier about how will you work with the local project to make sure that you get informed? I think there is a huge benefit of keeping the conversation both directional, let's say, from operators to infrastructure owners to the NSPs, the authorities, the regulators, and so on. So, and I open like the invitation to everyone to make sure that we need also your recommendations, your input for any standardization or regulatory, let's say, overlook or deep dive into, so that we can recommend back to EASA or others to make sure that at least we're not overcomplicating, we're not over standardizing, but also at the same time we want to make sure that it helps operators gain more confidence and more freedom as well to operate. So we're looking at safety, obviously, but also at the automation of operations and increase of operation. And I think, yeah, that's the right path to start with.
Yeah, I fully agree. So we need to listen, we need to engage, we need to conversate with the people involved. We need to achieve social acceptance, and for that we need to answer the question from the public, so they are able to leave the room and say, okay, now I understand a bit better use space. So anyone have a question? Yeah.
My question is about public acceptance. Do you have any specific tasks that you are planning in order to achieve this social acceptance, or in order to make the public much more concerned about U-Space and drones?
I'm happy to jump into this. So one of our partners in the DSD is Deep Blue. So Deep Blue comes from a background of a human factor, and they will be leading a full work package looking at the social acceptance, which is very important. It's not only for use-based implementation, for all aspects of it, like even beyond that. And I think over the dinner yesterday I was sharing a funny story that probably most of you know about Mana drone deliveries. They're doing deliveries in Ireland, and when they moved to a new town, starting to look at their route planning and everything, one of the ladies complained and said, look, my chicken at the back, they're not anymore laying eggs in the chicken coop, so please, I don't want any drone nearby. So they have to honor that requirement, but at the same time, all the neighbors as well, they won't get deliveries. So, you know, all of these kind of use cases will always pop up depending really on what's accepted and what's not. So when we hear the siren of an ambulance passing by, nobody complains, because we know that there will be a life maybe that will be saved at the end of the journey, and probably there will be a piece of that as well. So if we know what is the drone operation going for, there will be kind of complete acceptance of saving life at the end of the journey. But when there is a suspicious operation around GDPR compliance and privacy in all of that, then yeah, it's very important to look at the social aspect and social acceptance of these type of operations.
Any other else want to add something? Okay, let's go to the next question. Alina.
Thank you. Well, I can add something to the to the question raised by yes, this lady. Well, in Spain, we are planning to do a survey for the citizens in the near future about gathering information about the social acceptance and how are the citizens thinking about this drones topic and the US space topic. So yeah, we are planning to do that in this 3-level coordination mechanism. We are going to imply also the general public at some point. And then I have a question for Luke. Yeah. Do you know or which are the criteria for the designation of the first US space airspace in Belgium, this less complex US space airspace? Do you know? Yeah.
We already choose the implementation. Just it's not secret. It will be a port.
Okay.
It will be a geographical zone with let me say a very hard condition to access, and it will be additionally you will have a reserved airspace. So it means with a hard condition to access as well. So it means that you manage the entry of drones, you manage the entry of manned aviation. And then it's not a urban, environment. Nevertheless, you have some complex mission with fire brigade, with police, with all these kind of things. So it's not easy, but it's less complex. And we choose this port without risk assessment. We say that we will do that. This is why I talk about the a temporary use space airspace. And then if it is positive, and then if the risk assessment, the conclusion of the risk assessment is that, yes, it should be a use space airspace. It should be a use space.
Okay, so they are not concrete, specific, for example, the reasons or security reasons no.
Not for the moment.
Okay.
It's really to create procedures and so on, and then we'll do it.
Okay, thank you very much.
Okay, and I think we don't have time for more questions. So at the end of the day, you can come back to us. It's good for us to be able to communicate what we are doing, the different projects and the different initiatives. I think it's essential that we engage with the public so you all know what we are doing. So thank you very much. I hope you have enjoyed, and thank you very much to my panelists. Thank you. Thank you.
Ya podemos aquí los cuatro. Sí, ¿no? Okay. Falta una botellita de agua aquí. Espérate.
Hello. Hello, everybody. Good afternoon. Thank you a lot for staying until now. This is the last round table of the workshop. I'm Andrés Abrego Arlegui. I'm member of NITEC. I've been working in prototyping drones for the last years. I would like to thank you all, your assistants, for staying until now. Also for the people that is still following us on the stream. Also, I want to thank you to my colleagues that have been organizing this workshop. I think that has been really interesting. Now I'm going to make a short introduction of my colleagues, and they will have time for a short introduction about the main goals and achievements that they have reached during this eMove 3D. And let's start with Dr. Antidio Viguria. He is a PhD from the University of Sevilla and CTO in avionics systems at CATEC Technological Center. He was a researcher from 2006 to 2008 at the Georgia Institute in Atlanta, in the United States, granted by a Fulbright grant. He's the author of more than 90 peer-reviewed publications in US and aerial robotics, with more than 15 years in the US sector. Has participated in more than 80 research and development projects in the last 15 years, and is coordinating a team of more than 50 researchers and technicians. Also, he's currently the project coordinator of piloting H2020 project. And finally, he's member of the board director of Eurorobotics, and he led the SORA focus area in EuroCAE, workshop 105, from 2017 to 2020. Please, Antidio, if you want to talk a little about the...
Yeah, so thank you very much for the kind introduction. Thank you again, everybody, for staying here until the end. We have a aperitif afterwards for those who can't stay until the end receipts. So basically, Well, as it was just mentioned, I'm the technical director of CATEC. We are a technological center focused on aerospace technologies. We have two main lines of developments. One is drones, aerial robotics, UAS, and the other is advanced manufacturing. For the drone part, I would say that apart from having a big team of more than 50 people working on US technology development, we also manage the Atlas Center, which is a test experimental flight center. Regarding our role in IMO 3D, okay, we have been focusing on the development of technologies that increase in some way the safety and the efficiency of the operations. We're really much focused on the autonomy part of the UAV, so we think that autonomy will help in these two aspects, mainly safety and efficiency. For example, we are developing detect and avoid technologies for obstacles that the drone may encounter in urban environments with onboard sensors, like for example LiDAR or cameras. Also, we are developing advanced trajectory replanning for tactical deconfliction in a U.S.-based environment in the project. And also we are working on multi-UAV cooperation. And for example, we have been developed a set of technologies that allows to have a team of robots to cooperate to complete missions and to be able to be supervised by a single operator. This was actually awarded with the Fundación en Aire E Plus Drone Prize this year, and we are very honored of that. And I think it was a good summary. Thank you.
Thank you. Thank you. Okay, now it's turn of Mr. Jorge Soane Landariz from ETG. He holds a 5-year degree in telecommunications engineering, specializing in telematics from the School of Engineering in the University of Vigo. He also has a master's degree in information and communication technologies for mobile networks from the same university. And he joined ETG in 2009, where he is currently research and development manager in US division. Through his professional career, he has participated in more than 20 research and development projects at national and European level. You want to make an introduction?
Yes, thank you very much for the introduction, and thank you everybody for being here today. Well, I suppose most people here knows ITG, but we are a national technological center founded in 1991 in A Coruña. We work in 5 different activities in energy, in sustainable construction, and water, ICT, and of course in unmanned aerial works, aerial vehicles. For us, the IMO 3D network give us the possibility to improve and to fortify our role and our position as drone expert, and also to communicate and to disseminate the result of our research. Talking about technology, we work in this project in 2 lines: in autonomous aerial robotic, for example, for precision navigation and landing, and also in drone traffic control, developing digital U.S.-based services, and doing large demonstration, for example, for urban air mobility.
Mm-hmm. Thank you, Jorge. Okay, now it's turn for Dr. Aníbal. If you are into research and investigation, I'm pretty sure that you have read some of his articles. Dr. Aníbal Ollero is director of the robotics laboratory in the University of Sevilla, with more than 70 members, leading more than 70 members on average in the last 5 years. He's also the scientific director of the Center of Advanced Aerospace Technologies, CATEC, in Sevilla. He has been full professor at the Universities of Santiago de Compostela in Vigo and Malaga, and researcher of the CNRS in Toulouse, in France, also in the Carnegie Mellon University in Pittsburgh, in the States. He's the author of more than 850 publications. 850 publications. That's a big number. According to Scopus, he's the author with the most publication on UAV and aerial robotics. He also has 5 articles among the 15 most cited in systems with multiple unmanned vehicles. He has directed and participated in more than 180 research projects, including 45 international projects, being coordinator of 7 projects, consortium of the European Commission Framework Program on UAVs and aerial robotics. He has an advanced grant from the European Research Council, and he has transferred technologies to companies in more than 90 contracts. He has received 29 awards, including the National Engineering Research Award in 2021, the Rey Jaume I Award in New Technologies in 2019, and the overall winner of the ICT Innovation Radar Award from the European Commission in 2017. He also has the Andalusia Award for Engineering Development in 2022 and the National Automatic Award in 2022, and many others. It's a pleasure to have you here. Please, if you want to.
So thank you. I will try to say a few things. Yes, it's a big group at the university. I will concentrate on this group and not in the CATEC, and Tidio concentrate on the CATEC. So we are right now participating in about 13 European projects, and I'm coordinating one of them, which is Aerial Core, and also I have the advanced grant. I will try to mention today, I don't know where, but I will mention. I have 7 research projects, Spanish project. Now with the resilience and all this, we increase the number of Spanish projects. It was minimal. Anyway, the funding is minimal, and we have 12 contracts with industries. Okay, so you mentioned about publication and awards. So I think that we are moving from TRL 4. That means that we are working at the test beds and developing technologies at TRL 4. And then we produce some results at TRL 5 in most projects, and in some cases 6. In that case, together with CATEC, typically, we also work with companies, try to improve the TRL of our product with the company. In the last year, we got new projects, mainly on the UAV technologies, as always. We have been working on this more than 25 years. So we have many because we start pretty soon. So it's not so difficult. So we start 25 years ago. Yeah, I think that we also got some projects dealing with applications, not only the UAV technology, but other applications. So we are starting now a consortium to coordinate aerial, surface, ground vehicle, and marine vehicle, surface and underwater. We are working on this in a project coordinated with Navantia, and also with a number of projects related with technologies to increase the reliability of the UAVs. So in here in IMO 3D, we have been working together with CATEC in increasing the decisional autonomy. So that means essentially being able to fly without any kind of conditioning of the environment, and just mapping the environment and landing with accuracy, thanks to the use of simultaneous localization and mapping technique. So that means that localize where to land, and land, for example, to recharge the battery with centimeters accuracy. Also, this is for autonomy, but I like also to increase the safety, not only in the more classical way of detection and avoidance, but we are developing, let's say, soft aerial robots. So we wanted to develop, and we are developing now, soft aerial robots. And finally, yes, we also work on the coordination. What means coordination and cooperation? The coordination means that essentially to share properly the space in time also, and the cooperation means to solve missions. For example, in the inspection of not only one line, but a grid of lines. Endesa was here. And in the AirCore project, we developed a system that fully autonomous with 4 UAVs, multi-rotors and VTOL. The VTOL, the multi-rotor from the university, the VTOL from FUVEX. FUVEX is also here. We're able to inspect several lines at the same time in May, demonstrating with no action from the operator. Just press the button and then inspect all the line in 10 minutes, optimizing the trajectories and optimizing the time in 10 minutes to inspect several kilometers. So I would say that these are the main things in aerial core, but also in IMOV 3D, because the coordination of the multiple UAV. So this is more or less trying to summarize.
Yeah, at the end, the clock is ticking. Okay, and now is the turn of Dr. Raquel Herrero from NITEC. She graduated in chemical science from the Universidad del País Vasco, and she's PhD in material science from the Manchester Metropolitan University in 2001. She's project manager in the mobility business unit at NITEC, and she belongs to the advanced manufacturing and sustainability knowledge area. She has more than 15 years of experience in product development using functional printing and printed electronics. She has 2 patents related to this technology and is an expert member of the International Standardization Group TC 119 for printed electronics. She is in the eMove project. She is the eMove project manager, and in addition to coordinating the activities carried out in the project, she leads the advanced drone manufacturing part by combining printed electronics and 3D printing of composites.
Thank you, everyone. Thank you, everyone, for being here and for staying until now. Well, as you have listened, I'm the outsider from here. I'm not in the drone area. I'm the project manager of this project at NITEC, but I'm from the advanced fabrication part, and we are using this advanced fabrication for doing new drones with new platforms, with new characteristics. NITEC is a research institute which is situated in Navarra. We are focused on mobility and mechatronics, and we are around 80% and 30% of us are PhDs. We are divided in different business units, and one of these business units is mobility. In the mobility unit, we work in smart mobility and also in green mobility. And is in this unit, we include terrestrial equipment and also drones. We started working with drones thanks to this project, to eMove 3D. And for us, it has been a really, really good opportunity. During these 3 years, because, well, as most of you know, project is finishing. During these 3 years, we have been working in areas like the other technical centers that are here, developing solutions for autonomous landing and detect and avoid. And also, we are also working in predictive maintenance of batteries of motors. But one of the big part of our work, which is a big different from our colleagues' work, is that we are also using printing techniques like flexible electronics and 3D printing to create new platforms with new characteristics. For example, we are substituting the cables of the drones, of the frames, doing printing them with conductive materials. We are also developing 3D conductive materials, so we are able to print a frame of a drone using ABS, normal ABS or normal ASA, combine it with the conductive materials. So at the same time, we fabricate the frame with all the conductive parts of the drone. And also we fabricate the composite part with 3D, and we are embedding, for example, strain gauges, which permit us to control the landing force, or also to see how the structure of the drone is, and we can predict if we will have cracks, or we can detect cracks and some failures of the drones. So it's a bit different from my colleagues are doing, but I think that is also something necessary for this business and for the industrial part of it. Thanks.
Okay, thank you. I think that you have a little insight of what the technological centers have been researching for these 3 years. Now also, this roundtable, we are going to talk about the flight test centers that has been developed also in the IMUFT project. So please, if starting with Antidio, for example, if you want to show us a little, we also have.
So first of all, I would like to comment that being the capability to perform experimental flights is now key for the sector. It's a moment that we need to test all this technology that we have commented during the day. It's important to come with this capacity as a country and also in Europe to be able to fly. You can see in the video, this is our Atlas facility. It's located in Jaén. It's like a small aerodrome, but it's just fully oriented to UAS operation. We only perform UAS operations. It comes with a 600-meter runway. It has 2 main hangars and then a third one that was constructed this summer. And also we come with a primary radar to be able to survey the area, and some ADS-B receiver, and also we come with a 5G network infrastructure. Then I would say that from Atlas we have 2 main characteristics that they are not, you cannot pay for them, I would say. No, it's important. That's why it makes it so unique. One is the weather conditions. Okay, we have more than 300 operational days. This is something that you cannot pay. Okay, an aerodrome is 5 million, you get an aerodrome. 4 million, you get an aerodrome. Weather, you cannot pay it. So this is a unique at the moment. But I think it will take a long. More than US space, I think. And the second key issue is that we have above Atlas a segregated airspace of 30 by 35 kilometers, 1,000 kilometers. So it's a it's a place that you can perform easily BVLOS operations, experimental flight operations. We have had we started operations in 2014, almost 9 years ago. And we have had more than 70 clients, And for example, during last year, we have had Lilium performing their VVLOS operations there. And also we are having regularly R&D projects, and this is a facility that is open to any kind of partner industry, university, technical center that would like to use it. And I would like to take the opportunity that you are seeing the flyers in the entrance that we just have an agreement with another aerodrome called Atlas Tactical Center. It's the BEAS aerodrome. That is only 25 kilometers in that straight line. And we will have a IMO-free demo day in the 8th of March. So you are most invited to come and you can register through this flyer. Okay, thank you.
Thank you. I will remember also the demo day later. I just kept with the weather thing, especially with Jorge here. It's like we in Pamplona also have issues with the weather, but I think that other people have more bigger issues. Okay, now please, Jorge, if you want to talk a little about the Galaxy Lab and Ancora.
Okay, let's start the video. Well, actually, ITG manage two different drone test centers. each one focus in different use cases. This one, as you can see on the screen, is Ancora, located very close to the sea, as you can see, in the north of Lugo, with a very different weather of Atlas, of course, but this is also interesting to have different weather and different situations for test. But well, Ancora is located in a 2,500 square meter parcel. This infrastructure is basically a vertiport with office, hangar, water station, video surveillance, etc. It is a perfect scenario for a managed operation, both aerial or maritime, because the lower traffic density and also the direct access to the sea. In the last year, Ancora was the scenario of different tests and demonstration, but I want to highlight some of them. The first was a maritime rescue simulation involving the national emergency authorities and using drone for detection of the victims. The second one was a U.S.-based deployment in the very large demonstration project Domus. And the third one was in October of 2021, where we do an iMove 3D technology demonstration with the collaboration of the rest of the technological center of our network.
Okay.
The second one, drone test center I want to talk to you is Galaxy Lab. We're going now with the other video. Yes, Galaxy Lab is a completely different test center because it's located in a urban scenario in the city of A Coruña, in a technological park under construction, promoted by the municipality of A Coruña, the University of A Coruña, and also our regional government. Okay. Our lab, Galaxy Lab, is now also under construction, but this infrastructure will provide an indoor lab. Is this lab you can see there with more than 100 square meters, with a flight control center, indoor flight zone, electronic laboratory, assembling, test and verification, 3D printing, office, meeting rooms, showrooms, etc. And we will complement it with another infrastructure, and we will provide a vertiport and also a flight cage. And just to finish this infrastructure, we are also equipment a ground control station, a mobile ground control station. This test center will be completely with the deployment of a US-based area. Well, I think Galaxy Lab will be a perfect scenario for developing and testing urban air mobility solutions, such as, I don't know, maybe package delivering or US-based integration. Thank you.
Yeah. Beautiful. Okay. Now, please, is Aníbal.
Yes, I think that I have a PowerPoint presentation.
Oh, okay.
I can put the quote. Okay, so this is the Center for UAVs and Urban Air Mobility. So next slide, please. Is here? Okay. So you can see here the motivation, essentially. The motivation is essentially the market and the prediction in the market, and also related to the population in the urban area. So you can see the numbers in this exponential growing. Essentially, the motivation was the traveling time, the zero emissions, so electric, so new services that now are not possible, and then integration in the smart cities concepts, and then this is also a big market. So, so it's located in Seville. It's the University of Seville and Fadacatec, main actors here. So it used the expertise of the leadership of these entities in aerial robotics and UAV technologies, and we'll have two facilities. One is very close to the CATEC facilities in Aeropolis, very close, and the second is in Tablada. In Tablada, because it's an agreement with the Spanish Air Force, and then we will have an hangar there and some vertiport also, and we will perform operation from there, which is good because it's also very close to the river, and then we can fly in an urban area and close the river, so we will have this environment. It's funded by the regional government, and the objective is obviously to develop technology, so it's a technology center to develop technology, but also to transfer to the companies. So you can see here as what is included. So it's cargo, freight, transportation, and so on. And according to the SKU that you can see, but I cannot, is something that is growing faster. And then you have the transportation of passengers, which is something that requires more time, and then also certification. And then we expect that will be starting in 10 years, essentially. But now is the time to develop technologies for both of them. So next, please. No, okay. Okay, now what we want to do, these four axes. First, increase the safety of aircraft. Obviously, this is important, and we want to develop technologies for different point of view. I will try to explain. The second is the ground infrastructure related with the vertiports and so on. The third is the integration in airspace. And the fourth, we talked before about the social acceptance of the technologies. We think that this is related with the variables that can be directly very well perceived by the public. But the second is because I think that the public may change the perspective if this system offers technologies, new technologies for them. So what we wanted to have is included also last mile delivery and transportation. So we started with this, by the way, in 2009. So this is not new. This photograph is the transportation of loads in 2009, between 1 and between 3. So this was done in 2009. But now we wanted to also to include more safe, I would say safe, extremely safe systems that are able to perform things like, for example, hundreds of grams by flapping without propellers, no propeller, flapping wing. Can you activate the two videos? I cannot activate the video. You know where to activate these two videos below? So these are two videos with flapping wing. For the flapping wing, we develop systems that are able to improve energy consumption when comparing with fixed wing, which is extremely difficult, but obviously the key point is gliding. So if we are able to glide significant time, and then we are combining the flapping wing, then we can significantly save energy. But not only that, now we are developing, well, these are the first intelligent birds, robotic birds in the world. So we are able to fly without any kind of piloting from remote pilot, but also more recently, we are able to perch, fully autonomous perching. So that means that you can be at home in a floor and then ask to our bird, and then your bird will grasp, and then we perch in your in some place that you can have to perch, and then it could be possible to deliver a small hundred of grams. So this could be this is possible now. So no video. Okay, you can believe me. And then increase safety. What means increase safety? So intrinsic safety, I was talking about increasing safety. It is not only collision detection and avoidance, it's to absorb the energy in the collision, and then finally try to develop new, more soft or completely soft aerial, unmanned aerial vehicles. Right now, we have been working with the flapping wing, which is very soft, hundreds of grams, but also we are working with multirotors, with soft propellers. Yes, we are working on soft propellers. Not easy, by the way, but we are working on soft propellers. So this is something that we wanted to have. Of course, and this is because I do not agree with you, because we think that it is very important and we work together. We would like to work together, embedding sensors in the airframes and embedding and producing. So I would like also to produce the UAV just by using the additive layer manufacturing. So yes, I think that this is quite important. And I think that this is something that we also need to combine for increasing safety, together with reactivity and more classical topics. I think that we need to discuss about energy and safety and efficiency and safety. And how to combine this concept, this will give some papers, by the way. So that means because there is always some comparison, and it should be very serious and scientific comparison. But I think that this is needed. So next, please. But by the way, it is possible to embed in my birds. My birds are able to see obstacles flying and then to avoid in real time, just with integrated in the electronics and with cameras and so on. So we also have the vertiport. I have a video from Nacho on the top right. Okay, no problem. He passed it to me because we are collaborating with the Global via Blue Nest and so on. So we are discussing about how to implement automation in the vertiports, which is, I think, relevant also, together with the fully autonomous landing and how is the problem with the battery interchange infrastructure. This is gonna be difficult, right? But of course, we also wanted to have safety in passengers and cargo. So. Well, the airspace integration, you have been talking a lot, so I don't need to detail more. But of course, we want to have low-level conflict, and as I mentioned, GNSS degraded or denied navigation, and multi-UAV planning at different levels. So that means that we are planning the mission, we are planning the different tasks by different UAVs, and we are planning also the trajectory all together. So I have two nice videos in which you can see, for example, the cooperation of the VTOL with the multirotor. The multirotor, the key points are to take into account the energy and also to take into account the wind. How to take into account everything in such a way that they go to recharge the battery only when needed, and fully autonomous recharging the battery now in platform to recharge the battery. In the future, from the electrical lines, for example. Yes, we think that it is possible. We are developing also technologies in aerial core to recharge the battery from the electrical lines. And finally, is my time? Okay. So the integration in multimodal control. So I am finalizing. The technology, let me finalize these technologies and services for the society. Well, obviously, in addition of the no emission and so on, we have to take care about the security and the privacy, but we also need to take into account to decrease the acoustic impact. Some of these aerial taxis are very noisy, so we do not want to have this. We want to decrease the impact. And also, I think that the people will be more in favor of this technology if provide something that is quite evident, taking into account emergencies, personalized health services, service for handicapped people, and also integration of the rural periphery. So these are the key points in my opinion. So working in the center, we are working in the center now. We are working on the equipment specification, all this, including manufacturing and testing equipment and so on. So simulations related with the US space and so on. And the facilities, we have to spend money in the facilities in Aeropolis, but also in Tablada. It's a big hangar, 100 meters. And then there is an infrastructure for the vertiport, and they also will take care about their space management. So, and also we would like to have agreement with companies to launch this center and to have joint projects, as we did many years ago in CATEC. So I think that this is quite possible, and we are very open to collaborate with the company from another technology center from today. No, from now, I would say from now. So thank you very much. Sorry, Antidio.
No problem. I have to say that I have seen those videos, and I'm completely in love with those your birds or those ornithopters.
I like my birds. I have to put my.
Maybe you also have seen videos of those ornithopters, but the ability to birds to hang on sticks, or that's the intelligence that they have developed. It's amazing. Okay, now it's turn to Raquel. Please, if you want to make.
Yeah, I want to present the Navarra Navea Drive Lab. This is two different scenarios for testing terrestrial and aerial equipment. One of them is the logistic lab, which is situated in Estella. It's like 30 minutes from Pamplona. This is a lab that, these pictures, these videos from 1.5 years ago, more or less. So that was when we started with this lab. But nowadays is almost fully equipped. And the objectives that we have with this lab for logistic testing is to develop vehicles for autonomous movement and for intralogistic gestion. We want to work with collaborative vehicles, drones and rovers and terrestrial ones, and with robotics also. So this laboratory is equipped with like different areas. We have a closed space for flying drones, indoor flying drones, which is equipped also with ultra-wideband sensors, so we can do autonomous flights and control the situation and where the drone is flying. We also have a control center for the planification of the missions, and a micro hub equipped with robotics and with a robot and with terrestrial vehicles, so we can do some tests between collaborating between all the different test scenarios. And we also have a lab to when we create our own drone platforms, as I told you, using 3D printing and flexible printed electronics. And the other scenario is a urban test bed, which is situated in Pamplona. We signed an agreement with the town hall of Pamplona 3 months ago. And we have, the objective that we had, it was to create a reference environment that allows the design, the testing, and the deployment of different technologies and functionality, all of them associated with electric, autonomous, and connected vehicles, terrestrial and aerial. It's a 2.3 kilometer circuit in an urban area. It's located just next to the Public University of Navarra. And it has like very interesting characteristics in terms of mobility, because it includes the football stadium of Pamplona and also an arena for concerts. So we might have like different situations with a lot of people. So we can do different tests and all that. This urban circuit is equipped with different sensors. We have cameras. We also have fiber sensors, which we use to measure traffic. We have been doing some projects where we have been doing the fiber sensors that are installed for other applications. and we have been using them to identify the vehicles, the terrestrial vehicles, and also the speed of those vehicles. So now in this urban circuit, we have installed the cameras and also different fiber sensors. We have also a radar, LiDAR, and pollution sensors. And we are starting to do some tests for the moment terrestrial with terrestrial vehicles, because we, well, you all know all the paperwork that you need to fulfill to be able to fly with drones in an urban area. The good thing about this urban circuit is that we have the collaboration agreement with the town hall, so we can close it, the whole circuit, with some exception, the emergency vehicles and buses, but we have a collaboration of the local police. So I think it's a good opportunity to test different scenarios of collaboration between all vehicles. I mean, as you saw, we can use, we have an electric platform, like a small truck. We also have different rovers, drones, and we are starting to plan different test scenarios to try new technologies that we are developing. And I think that's all. We are open to work with different technological centers and also industry.
Yeah.
And I think that's it.
The next week we are going to make a test
next week we are doing first test with terrestrial vehicles.
Yeah.
And we hope that in a couple of months, maybe, we can start doing tests with drones and terrestrial vehicles.
Swarm things. Yeah. Thank you. And you say that Atlas is already available. For what users it's designed for?
So we have to, I would say, two main kind of users. One is already established, so it's entities that would like to test new technologies. So companies that would like to test the developments, or R&D projects that they need to perform experiments. So this is one of the, I would say, now customers that we have right now. And we have also started to see users that they would like to perform experimental campaigns for the, I would say, all qualification or certification, whatever you want to mention, of the different categories. For example, for the open category, for some of the qualification flights they are performing Atlas. For the specific category, in order to go obtain or fulfill the design verification process, you need to perform 3,000 hours. It's true that not all of them has to be performed in an experimental test flight center, but some of them, probably the most riskier one, it could be wise to do it in an environment like that. And of course, for the certified category, in order to obtain necessary evidence. So this is something that has started, I would say, in the last 1 year, 1 year and a half, and we think this will increase in the next year. So I think these are the two main type of customers that we have and we would like to have in Atlas.
This drives me directly to Jorge, because Ancora it's already working, but when will the Galaxy be available for people?
Well, in building, is when you start, but it's difficult to know when you're going to finish. No? But in this case, it seems everything is going well. The deadline was planned for the end of April.
Yeah.
I hope to be able to complete the plan and to finish the construction and deploy the U-Space zone to be available in next spring.
Yeah, we also have delays in the urban circuit in Pamplona, which has been the main issues that.
Well, the town hall signed the agreement to understand that to have and that is communication. It's something that is going to happen here. So for next elections, so that you get it. For so I think that was
yeah.
But yes, I mean, with
Okay, I don't know if there is any question from the public in attendance. Yes.
Hello. Can you hear me? Oh, yeah. Well, it's not exactly a question, but I would like to take the opportunity to thank the Spanish research centers and the researchers here for placing our country at the forefront of this industry. Also, I take in my mind almost 4 years ago when we were working in the Ministry of Transport on the National Strategic Plan on drones, we were aware about the extraordinary funding call from the CDTI, the Proyector Cervera. It was a specific funding for the technical research centers. And we identified that the strategic technologies that this funding was trying to attack were including the autonomous vehicle, but it was not clear by the time that the aerial vehicles were included. So from the ministry, we had some conversations with CDTI. It was really interesting to see that in the end, it was possible to cover this kind of project. And congratulations to show us how this difficult project can be handled by the coordination between different technical research. I don't know if which are the next milestones, and do you see some other examples to cooperate between at a national level between all these very nice infrastructure that we have here in Spain?
So now we are very happy about the project and the work that we have been achieving in the last 3 years between the 4 technical projects. Actually, we plan, if there is a new call, we plan to continue with some of the new challenges, but we would like to have a second part of IMO 3D consortium, if it's possible. Anyway, we have been discussing that we would like, even in the case that we don't have a project backup, that we would like to continue to have this workshop next year. So we hope to see you, all of you, next year in the 4th edition of the workshop.
Yes.
And there is a lot of challenges. I think that we have seen today that there are a lot of challenges in safety, in autonomy, that we need to push, and in BB-loss operations. So they are necessary in order to really create an industry. I think that Spain is well positioned in the sense that we have good actors in technology at the universities. We have a very important traditional aeronautical sector, but what is lacking that all this knowledge and everything is we use it to create a real industry drone sector in Spain, and also with the support of the ENAIRE and DGSE and EASA and the government. I think we are in the right moment, and hopefully we can put our 2 cents to make this happen.
Thank you, Antonio. And I want to remark that by that time, this project was the most successful in funding. So you could tell that there was a real national interest on this topic. So
thank you.
I don't know if we have time for another.
Now, about this question about collaboration and so on, I think that we always need to maintain the collaboration with the industry. So we are right now applying some technologies that we developed 15 years ago, but we need some maturation. So this is impossible just to transfer immediately. We need some maturation. So if we want to have technologies in the 2030, we need to do a lot of things now. And later we will work with companies. And I mean, I think that this transition in our case is also more easy because CATEC essentially, right? So CATEC is a technology center. We develop technologies at the university, also at CATEC, but it is clear that there is more, if you want to, there is more proactivity in CATEC to link with the university. Even that we have been working with the companies for decades. So that means that we always need this motivation of this view from the company. But at the same time, we need to be in the forefront of the new technologies. We need to discover what will be needed and what are the gaps that we have now. And this is something that we will need to solve the only way. Of course, we have constraints, so we are not in the economical forefront, by the way. So that means that we also suffer from this. We know what means that when you have a person that you spend 10 years or 5 years just with informing the background, the work, they go immediately out, so because they pay more, essentially, right? So how to combine this, how to attract? I think that one important thing is of this center is to attract and maintain people. This is the most important, right? If not, that would be very difficult.
Okay, I think that we are already late. This might be a good finish. Just as a reminder, Mr. Antidio already invited you to the 4th meeting next year. You cannot save the date yet, but yes, you can save the date for the demo day, the 8th of March. We will be showing final products in the final research as a demo in Jaén, in the Beas de Segura airfield. So you are more than welcome. You can go to the website and make the. Okay. We have a small lunch here now. I think that it will be quite late.
Pequeño vino español aperitivo. So you are more than welcome to stay, and in the basement there will be some coffee and something to eat. And again, on behalf of the whole consortium, thank you very much for being here the whole day, and also for being until the last roundtable. Thank you very much.
Thank you.